morning, Stockholm. Welcome to day 2 of Developer Days. So just quick intro and then we're going to get right into things today. So today's basically broken into 2 big blocks. We're going to start the morning off and talk about sustainability. Bertrand will be leading the morning sessions. The afternoon, we're going to talk about AI, which I know everyone wants to hear about. Javier will be leading that. Then we're going to have the cool boat ride this evening. So I hope everyone is going to join us for that. Before we get things kicked off, we're going to have an opening session by Guru, who is our VP for product management for provider connectivity. And one of the things that I want to point out, so Guru owns both the automation and the routing portfolio within Cisco. And one of the reasons we do that is a recognition that operational simplicity, time to value, is all central to building networks, and they shouldn't be 2 separate things. So we have them all rolled into a single organization. We align priorities, we align messages, we strive for delivering simplicity. So without further ado, I will hand things over to Guru, who will talk a little bit about his view of simplicity in the network.
Good morning, everyone. Omar said it right. Arguably, one of the biggest reasons we do automation is to drive simplicity in the network. And it's the tooling is great, and it's essential. And we talk a lot about it, right? This event, for the most part, has been about how do you use automation capabilities and software to simplify the network. But one of the things I want to start talking about, if I can find is this the one? Yep. So one of the things that I want to start off by emphasizing is it's not just the tooling. The fundamental infrastructure needs to offer the ability to run simplified networks. And so, one of the things that we emphasize quite a bit internally at Cisco is how do we make sure that the infrastructure that we build, the hardware, the software, the platforms, the architecture, is all aligned to drive that simplicity that your automation capabilities can tap into. And so, we touched a little bit upon this for those of you who were in the audience yesterday when we did the panel. But I want to give you 2 examples and show how that matters. The first one is, how do we come up with simplified architectures at the fundamental network level, right? And this is a great example. It's an architecture we call routed optical networking. And this is really about bringing IP and optical layers together. You can see the picture on the left. It shows 3 different layers. You have the bottommost optical layer that's ROADMs and such, and then you could have an OTN layer in the middle, and then, of course, the IP packet layer on top. And for decades, that has been the mode of operation. And what we are moving to now, the architecture that's available today and already deployed in a lot of networks, many of you may be familiar with this already, is really that convergence of IP and optical layers. And so you essentially end up with a single layer that allows you to bring all of these together. Right away, visually, it's clear that the benefits are many. You have fewer elements to manage. Obviously, there are cost and power and other kinds of savings as well. But simply the fact that you have far fewer elements to manage makes it easier to drive that network and deploy all those services in a much more simplified manner. And when you do that, obviously, it helps you scale better. It provides better resiliency and all of the things that you're trying to do as you automate all of the provisioning, monitoring, and everything else on top of it. The other example that I want to give you is this one. If you look at this, it's a traditional network architecture. And this is a super simplified view of multiple domains, right? You have the access, core, edge, and then the data center. And if you look at historically how all these networks have been plumbed together, it's different protocols. At the transport level, you may have Ethernet for your access technologies, plain Ethernet. You could have MPLS in the core, and then IP in the data center again. And then you have the service layer on top, which is, again, maybe L2 VPNs in the access, L3 VPNs in the middle of your network, and then VXLAN or such to provide the data center services. And so plumbing all of those is an effort. And this is what, if you have this kind of an infrastructure, which exists today in a lot of networks, then all of the tooling no matter how much you simplify, how much you automate, you're still going to have to do all of that. And this is where some of the points that Clarence yesterday was making come into the picture. You can replace all of that stack of different protocols across domains with segment routing end-to-end. SRv6 is where we are going towards now, right? We've evolved beyond SRMPLS, as he demonstrated yesterday. And then a single service layer on top, EVPN-driven. And now this makes it much easier because your tooling also gets simplified on top of that. So this is just another example of how base infrastructure level innovation can drive simplicity and drive easier automation. And this is the point I want to make. You'll have a lot of great sessions as you go through the rest of the day. I think we have some amazing sustainability sessions coming up, and then AI. But as builders, one of the things we do is make sure that throughout the network infrastructure stack, we have architectures that drive simplicity. And as practitioners, you and us need to insist on that as well. When you go off into your real lives and work on automating things, demand that the network underneath should have that simpler architecture as well. And this is what we are all aiming for, right? Across hardware, software, and architectures. There's a lot of examples. I won't go into any other detail here, but I'll just call out a few things. When we talk of hardware, it begins by ensuring that we have the right silicon building blocks, we have the right platforms that have converged functionality, so you don't need to deploy multiple platforms for purposes, and then optics, right? Optics and optical is a big piece of this. So have that base infrastructure in place, and then the software, which includes a resilient OS that has all of the programmability and API capabilities we talked about, the right data model support, and so forth, for you to automate on top of. And then, of course, architectures. I mentioned a couple of examples, but there's more, right? For example, for subscriber management, there is the CUPS architecture. We call it the cloud native BNG. Lots of examples like this. And so I'll leave you with this thought. As we get into the rest of the day, look at architectures, come and talk to us if you need more clarity behind some of these. But I'll leave you with that thought, and I'll hand off to Bertrand next, I guess. Yeah. Thank you.
Morning. I was here last year, and we start to have the first session of sustainability. And what I'm going to provide you today, it's a quick update, and I will also take the reference of what we have done compared to last year. Today, we're looking at sustainability and look at what are the challenges we want to address. Because if you talk to many different people about what sustainability is, everyone will come with different ideas, different things. And let's try in this presentation to focus on really what is common across all customers. If you look at what we try to do with sustainability, of course, yes, to save the planet, but that's very large and good goal, but that's, we need to be more practical to that one. When I talked to different service providers, they told me, yes, what I want the most first is to reduce my energy costs. And you will see in the next slides that, and there is a big reason to that. The second one, which is, I believe, also super important, it's to match with the net zero carbon strategy and the roadmap of the company. And why this? Because first, a lot of companies committed to address the net zero carbon strategy. And on top of that one, a lot of banks and the financial company did that too. Meaning that if your enterprise, being service provider, being an enterprise, classical enterprise, wants to get funding from a bank, today they must have a net zero carbon strategy in the company to loan money to the bank. Otherwise, the bank will not loan you money anymore, or will loan you money with huge rates and with such very bad condition. And those are, to me, the two major reasons why we need to take care of sustainability today. Energy cost reduction and energy cost consumption reduction and to be able to address the net zero carbon journey. Regarding the electricity costs, I think that slide is explicit. If you look at the wholesale electricity cost in Europe, in Asia, in perhaps, I don't know for Sweden, but at least for Europe and UK, he has reached the cost has been multiplied by 700 at some point during the Ukraine war, the beginning of the Ukraine war, and now it's at 300% compared to what it used to be before. That means your OPEX has increased a lot, and that is not acceptable because it's increasing your OPEX so much. I mean, I was reading an article not too far ago saying that of the entire energy produced in UK, BT consume 1% of it. Then if you could reduce that 1% to 0.5%, we will save a lot of energy and reduce the cost for BT as an example. The second reason, it's like I mentioned, everybody has an agenda for net zero carbon. Really, it's about the carbon, not about anything else here. Not about the energy, but the carbon. And if you look at a little bit detail what net zero carbon strategy is globally, it's divided in 3 scopes: scope 1, scope 2, scope 3. What matters to us, it's mostly the scope 2 and the scope 3. Scope 2, it's about make sure that the energy that we provide, that we generate, it's carbon-free. Then that goes back a little bit to what I've explained before. Because if we reduce our energy consumption, it will be easier to buy energy that perhaps a little bit more expensive, but that are carbon-free. And then, in the long run, and almost all enterprise, all banks, all service providers have an agenda for 2030, 2030, which is about making sure that we also address net zero carbon from the production to the end of life of any product, service, etc. This is more complex because now you have to look at the carbon consumption from manufacturing, transport, up to the end of life of the product. This is really what I've brought up to now was really the 2 main reasons why we're looking at sustainability, and specifically in the world of service provider, but I think globally in many enterprises as well. What is our execution? What Cisco is doing about it? First, and the most important, it's what we do with our equipment. With our equipment, we look at the hardware, and that's many years of work already, and we continue, and we try to improve our hardware by developing new chipsets, by implementing and optimizing LAN card, the fabric card, by coming with new architecture that Guru was alluded to, like RON, Routed Optical Architecture, and also trying to optimize our PSU, our fan power supply unit, and fans. On top of that, our network operating system, that could be iOS XR, NextOS, and so on, we try also to take the advantage of that and to provide better consumption from a software point of view. With the power-saving mode that we have introduced recently, the telemetry that it requires for automation and monitoring of the energy, etc. And we really have that in the agenda. I'm not going to go into details today. There will be more session after that will go through that one. And then on the automation side, of course, we need to plan the network with that in goal. We need to operate the network with that in goal. We need to look at the logistic with that in as a goal as well. Okay, this is really what we are trying to do, and we are doing for the last few, I would say, 2-3 years, and perhaps more. And we really have a strong priority in addressing this within the company. But let's look at the bigger picture. Let's look at not just what Cisco delivers, but also how this is operated from a service provider point of view. If you look at how it operates, you need to look at the big picture, meaning how much energy do I spend to operate those equipment? And we have something that is frequently used in the data center called the power usage efficiency. What it is, we are looking at how much power get in the data center and how much power get utilized by the equipment. And the rest, it's used, consumed by the distribution of the energy and by the air cooling and those type of functionality. Now, if you look at, I will take an example in Europe, the company OVH and T-Loop is doing the same, and they will be the next after me. What they do, they operate data center with liquid cooling. And what gives them, they do have a PUE of 1.25, meaning that for every single watt consumed by the server, they're consuming 250 milliwatt for the distribution and the cooling, which is very low. If you look at the service provider facility or street cabinet or whatever data center that you have in general in service provider, the PUE, it's about 2.0 up to 3.0, meaning for every single watt that is consumed by the IT equipment or router, you consume 2 more watts to distribute it and to cool it. And the main reason is a lot of those facilities are still powered with 48 volts or minus 48 volts. And that's super inefficient because when you have minus 48 volts, you have the inverter, the rectifier, the cable, which are all losing power to distribute the power. The second problem with that is that you are limited in the number of power you could deliver per rack. You're limited to 4.8 kilowatt in general. You could not deliver more because that's already a 100 amps cable, which is a cable that is that big as my thumb. And for all of those reasons, this is super inefficient. For all of those reasons, because it's limited to 4.8 kilowatts, and today, in a single rack unit, you could consume that energy, you basically have a real estate problem as well, because now you have in one rack, one device that is one rack unit, and then you could not plug anything else in that rack. Everything is empty. And then you have another rack with one rack unit equipment. And that's a big problem too. Then what is the solution? The solution is to move to much higher voltage solution, like 380 volt DC. But for that one, you need perhaps some other technique, which I'm going to talk about next. To address that, because the problem with 380 volt DC, it's about providing security, safety for the user. I mean, it's not the same thing operating at 48 volt compared to operating at 380 volts. And that's why you have a new technology emerging called fault managed power, which is to be able to inject some data information into your power cable to detect when there is a short circuit or a shock or anything that has to do with safety. And by doing this, by integrating the digital electricity, if you like, inside the power cable, we could now provide the same set of safety as you do with 48 volt, but running at 380 volt or 600 volt if you want to. And that's emerging technology. Cisco is looking at that one because we do believe that, at least for data center and for facility in the service provider, this is a good option to increase the voltage and then the power per rack, reduce the amount of the size, the section of the copper that you need to distribute this electricity. I think it's time to look at together how we could move forward to do a better distribution of the power. The second problem is that, assuming now I deliver 40 kilowatts per rack instead of 5 kilowatts per rack, the second problem will be, oh, but now I need to cool 40 kilowatts, not 5 kilowatts anymore. And for this, I think there will be no miracle. For this, we will have to use liquid cooling to address that one. We will have to basically reduce the heat of those equipment with liquid. And then you have two technologies. One which is on-chip liquid cooling, which is what we are seeing today with OVH, with others like T-Loop. Moving forward, we're already looking at immersion-based liquid cooling, meaning that I take the entire box and plug and cool the entire box into a kind of bath. And I believe that's the future, but we're working this. And yeah, if you're interested to learn more, contact me later. It's an interesting journey. Moving forward, it's for the net scope, the net zero scope 3, we also have to address what we call the PCF, the product carbon footprint. We will have to know for each of the equipment how much carbon I generate to manufacture, to transport, to package, to run, and to another live product, because I want to integrate that into my scope 3 vision. For that one, there are some standards emerging called ISO 14040. Cisco is fully compliant with that one. We're working in addressing that. If you ask the PCF for a product that we are delivering, we can deliver those information for the manufacturing, for the transport, for the packaging, and also for the end of life. This is a journey that we started 2 years ago. Now we are capable of delivering the PCF for every product, and we also address what we call the LCA, which is even bigger analysis. Here we're not looking at the carbon only, but we're looking at every single material that is consumed in the box. For example, the copper, the cobalt, the whatever. And we are doing an analysis of how much of each of the product, of each of the material it's used by the product. And we already have some analysis for 2 lines of product, at least the one that we are responsible for, which is the 540 and the 8000. Again, product carbon footprint, it's something that we're looking at. It's something that we have already. If you ask us, or if you ask your service system engineer, what is the carbon footprint for my product, it could give you this answer going back to our team, and we will be able to deliver those information. In summary, we started a journey many years ago. We started a journey by looking at how we could optimize the equipment, the network, and the automation of the network to basically reduce the consumption as much as we can. And we will continue. We have a roadmap, we have a software, we have a hardware roadmap to continue to deliver and to optimize the power consumption. But having said that, it's good. We are doing our job. But having said that, if we don't look at the big picture, if we don't look at how much energy gets spent by the facility, we could perhaps reduce 10% in our side, but if you consume 200 times those 10%, I think we're going to be a very little player in terms of saving. Then that's why we start to look at the big picture. We start to look at, could we build facility, could we build a data center running at 380 volt? could we start to look at liquid cooling as one way to move forward? And that is, to me, very important. We also start to look at providing information about every product carbon footprint. That is something that if you ask any SEs, they could go back to my team and we can provide this information for every of our product. And then this is really what all three subjects, this is really what we are after for the coming years. And in the next set of presentation, you will have our guest T-Loop, which are going to explain what they do here in Sweden. Then you're going to have Eric that is going to explain you how we are using our automation tools to basically allow to optimize the power consumption. And yep, if you have any question, I will be more than happy to answer. I still have a few minutes. Then you have any question? Well, okay. Then I would suggest that we move, and I will introduce T-Loop, which is going to give us an update of what they do here in Sweden.
All right, there it is. Good morning, everyone, and thank you for the introduction, also the possibility to be here. This is actually the first time I'm being able to talk to the guys, or being the reason for me waking up every morning going to the work, because I'm representing the data center industry, where we ensure cooling and power distribution to IT equipment. So I will guide you through our journey so far, and I will give you some updates what's happening within the market, and also talk about liquid cooling. So I have a lot to say about the numbers that we saw. For example, 1.25 of PUE, I would say that we could do 1.1 without doing any energy and heat recovery. So this is a quite offensive slide, but I think it's really important for us to cope in with this. I think it's all about sharing. And I think that's also one of the big reasons why you're meeting here. And I will get into why I'm saying that, but it's all about sharing. Yeah, so obviously you've seen me. Our marketing officer wanted me to add this in. So T-Loop is a 2.5-year-old company. We're about 11 people for the moment. And we really want to change the data center industry. So I've been working with data centers for about 12 years. And I'm really tired of the old conservative way to see how data centers should be built and operate. Just for an example, the heat coming out of the computers. That's really seen as something that you just need to get rid of. And in many cases, you need to buy electricity to ensure you get rid of it. Instead of looking at, is there any guys or facilities and elsewhere that would like to get that heat and heat the building, for example, or a pool or whatever it could be. And as the focus this morning will be about sustainability, I think it would be good with some dark pictures, because that's really the case, and it's really important that everybody within my industry and yours industry also to ensure that we focus on this for real. I think there is a quite strong light here, but I would like you to raise a hand if you think digitalization will be a key driver for making us achieve the climate goals. Because, I think we play an important role to ensure that we have the possibility to ensure more efficient systems and integrations in all different ways. But surprise, the digitalization drives huge electrification need. And this is really important to understand how we ensure the electricity supply to the IT itself. And I will show also some graphs and numbers on that on the next slide. Before we do that, at the moment, and for the last 7 years or something, we have seen IT going into these racks within the data centers for about 7 kilowatts per rack or something. As you saw, I think you said like 5 kilowatts and then moving up to 12. For the moment, we are designing for 50 kilowatts per rack. And that's really driven by high-density computing, such as AI and so on. And there's a lot of things happening within the data center when you move that high. And that's not driven by the data center. It's really driven by the hardware manufacturers and also the end customer behaviors. But there's some good things also with that. But from our side of the market and the data centers, everybody is focusing on high-density computing for the moment. Data center operators across Europe, everybody is hyping around AI. So they are going away from these 7 kilowatts per rack, only looking at 50 or even 100. HPE said last week to me that next year we will launch a cluster based on a 120 kilowatts per rack. And that's really something else. But it's also providing some possibilities. But at the same time, that application is really nothing I don't dare to say that, but we don't need it today. But it's really good if we would have it, of course. But it's important that we really use it in a good way and install it in a good way. So this is some numbers. I think, there's a lot of information here, and I think it's good to take part of. What's really important is to the right and just understand how much electricity and energy the data center will need within the coming years. And 20%, that's something that I'm really struggling to understand. Where will that electricity come from? For the moment, the big hyperscalers and cloud providers, cloud operators, they are scaling out in the Nordics to ensure that they have a zero CO2 footprint. I think it is quite easy to just buy the a low CO2 footprint, but it's one way. But when they are requesting and land grabbing, they are going to the utility company asking for, what I last heard, 2.5 gigawatts, 2,500 megawatts. And I just, that's about average power need for a city like Stockholm with a population of 1.2 million people or something, just for operating that data center. And they're also saying, well, we need it next year. And the utility companies say, what? That usually takes like 30 years for us to build. And that's not just Google or Microsoft. There's a lot of data center operators for the moment going for these huge locations for up to 500 megawatts, 1,000 megawatts. It is completely different numbers. And we're leaving the old 7 kilowatts per rack going for the high density data centers. And I'm very unsecure about how to power these data centers up. And it's quite interesting that there isn't any journalist so far that I've heard understanding this, because these numbers are telling me that the digitalization will suffer due to we won't be able to electrificate in the same pace. So there could be a reason that these huge data center deployments won't happen due to there isn't any power for them. So I think I will move on and go into the solution instead. So This isn't either about T-Loop itself, that will come in the next slide, but it's quite interesting to see where we have a data energy center in the middle, which is us and our concept. To the left, you're right. The energy sector, they are looking into how should we heat cities. At least in the Northern Hemisphere, that's a huge, we need to find a way to heat our buildings, as buildings are representing like 40% of the CO2 emissions. Grid balancing, our utility and utilities and the electricity system, it is getting lighter as we are pushing in more renewable energy sources. Because there isn't blowing all the time and the sun isn't shining every day, unfortunately. In that case, we need something to support that renewable energy supplies. And also, and heat and power during the peaks. And if we look on the other side, computing, what does that do? Produce a lot of heat. And backup power, that's also something that we have in data centers. And backup power, that's, as we saw in your presentation just before, it's about a huge energy storage system, which of course is built for ensuring that there isn't any spikes or disturbances going all the way through to the IT equipment. But have you ever seen a data center running at 100%? No, never. So the top that isn't used, why shouldn't we use that for supporting the electricity grid? To ensure that we have a 50 hertz supply all the time. And that's really what we are focusing on. And also redundant power, and that comes down to backup generation or power generation, which can take place in different ways. But it's really good on producing electricity and heat on demand, which we also install. So all of this thing on the data center side is within the data center. And we are investing in it, we are installing it, but we're not using it. We're only using the infrastructure when something fails. And that's really what T-Loop is about. So before we started T-Loop, I were a data center designer pushing for energy measures within the infrastructure. And it was very hard trying to turn the old conservative data center market and co-location providers. And I have a full respect of securing the operations. But at the same time, why shouldn't we be able to heat recover, for example? Why shouldn't we be able to participate on the electricity market with the energy storage? And just as also in the last presentations, we saw a diagram of what happened with the prices during the start of the war. As the gas disappeared, we needed to supply with something. And the CO2 went up to the roof, and the energy, which is a very expensive energy supply. And in that case, it would be terrific if we had a way to support with the energy storage that we have within data centers. And I think it is just for you to understand what the potential is. We had, a couple of years ago, one of the big cloud operators deployed a 500 megawatts of data center capacity within Sweden, which is the biggest installment today. That's equal to half of our biggest nuclear plant in Sweden. We have 5 of them. So that will be loading that nuclear plant for all hours a year, and at the same time producing the same amount of heat. And at the same time having 500 megawatts of batteries just standing there waiting for that nuclear plant to go down, which never happens. And at the same time having 500 megawatts of backup generation, which isn't used either. So looking into T-Loop, so we're really about being in the middle, and what I learned, being able to work or try to find circular economy or circular business models, you need to talk all languages. So previously, I came with the data center operator, talking to a property owner and or a district heating system, whatever it was that we were trying to integrate with. It was really hard. So TLOP is about standing in the middle, be able to talk the language of securing the IT operations, being able to talk to the building operators and the district heating system, to understand how could we integrate these systems to ensure that we have a full circular economy. And I think the most hyped thing for the moment, at least in the Nordics, is grid balancing. And grid balancing is really about the TSO, the guys ensuring the 50 hertz in the electricity system. They need to ensure that they have a protection for the biggest failure, which is 1.3 megawatts of nuclear plant in Sweden, which could go down. And in that case, the frequency will go down, and something needs to push in. What we have done is to using a UPS supplier which have this technology. We have looked for a company helping us to integrate between the TSO and our UPS, which doesn't exist. So we didn't find a company that were able to understand what the UPS is made for. They only understand how could we use the electricity and the power within the battery and push it out. But we want to ensure that we have enough power when the outage is there, of course. So in that case, me and Staffan, who is my co-founder for TLOP, we said, okay, we need to build this ourselves. And the next thought was, okay, but this will probably be something that everybody needs. So we're in the first steps of, we have found a hole on the technology side, but also understand this is something that will be there for the others, which is something that we want to share with them to ensure that all data centers will be able to share the infrastructure with the utility companies. So we will be more sustainable over time. So I think this is really something I also want to push for, and I'm hoping that you will reach out during the day, understanding more. And talking about liquid cooling, so we have deployed 3 for the 2-use liquid cooling rack here in Stockholm. So what I want to push for, small and efficient, that's really something it's connected with purpose-built. But it's so interesting for the moment when our industry is looking for the high-density computing, building these huge plants or campuses for data centers where they only relate to the AI application. And we don't know exactly where it will end up. But I'm quite sure that the utility campuses across Europe won't be able to power those data centers up. So I think it's important to understand there is limits when we are building a software or a application. At some point, we need to ensure that we can distribute the capacity throughout several data centers. And that's really a push for also when it comes to networking. I have a strong belief in edge computing for AI. So that's about inference, which I don't have the answer, but I'm really hoping that we will be able to install data centers in buildings like this, which could power this building and also ensuring the heating production for this building. But that will require a networking supply, which I don't have the answer for today, but hopefully you will. And also purpose-built, that's really what this is about. Building a data center for a specific demand is much better than building in advance. And highlighting true sustainability. So I think possibly Swedes or Nordics, we have come quite far. We have a huge supply of renewable power in the base load. But there's a lot of companies just buying the green electricity, thinking that's enough. For me, it's important to ensure that the reason why you have an energy need, that's optimized in the first step. Then, of course, you could try to optimize or install other things surrounding this infrastructure to ensure the maximum, the optimal operation. So that was really what I planned to go through. And yeah, exactly. There's a question. Can you share some example and current use cases for implementing liquid cooling? Absolutely. So we have, as I said, a data center here in Stockholm, which is I could say it is a use case for our concept data energy center, where a immersion rack is installed. And in that case, that rack is connected directly to that building's heating system, which means that the radiators on the floors in the building is really cooling the IT directly. And also across Europe for the moment, immersion cooling is really the end goal. And listening to our side of this industry, immersion cooling will be the end station. But of course, going for direct to ship is a step between, and potentially something that we need to cross. But at the end, liquid cooling will be the most optimal way to do it. So if there isn't any other questions within the audience, I would like to thank you for this opportunity and hope for a chat during the day. Thank you. Thank you.
Before introducing the next speaker, I will also answer to that question from Cisco perspective. Liquid cooling is very interesting for us for a few reasons. When we talk to, and specifically with AI in data center, when we talk to the GPU manufacturer, NVIDIA, etc., they are telling us the next generation and GPU and PU will only be liquid cooled. Then we could cool it by what we call on-chip liquid cooling. But then those GPU require memory, which goes much more faster. And then when we talk to the memory vendor, they say, oh, but next generation memory will have to be liquid cooling. And then the CPU guys are telling us the same. Then step by step, you discover that to build the next generation server, AI server, you will have to liquid cool not just one component, but 2 components, 3 components. Half of the box will have to be liquid cooling and sometimes more. And that's where immersion is going to play a big role. I believe that we will quickly move from on-chip liquid cooling to immersion with AI. Having said that, I would like to introduce Eric and Shrikanta that are going to give you an update of what we do from an automation point of view, because here it's a development day. Then let's look at what we will do from an automation point of view to try to optimize the power consumption when deploying equipment like a service provider and so on. Okay? You're welcome.
Good morning, everyone. So we have two. Okay, that's all. So good morning, everyone. What we would like to do today in the next sessions is really to explain how automation is going to help manage sustainability. So we'll start in this session to talk about Crosswork Network Controller and how we can help to measure and then eventually to optimize the energy measurement. I will be today. I'm Eric Orto. I'm a product manager in the Crosswork group. I'm here today with Sri Harsha, who is going to help and will give a demo of what we do today. I borrow this slide from Bertrand. So if you were not here this morning at the first time, just to explain why we are talking about sustainability. It's really top of mind for our customers. It's top of mind for Cisco. So not only want to save the planet, but probably more in a more concrete fashion. We want to reduce energy costs, and we want to reach those net zero targets. So if we want to do so, we need to measure them. We need to measure energy consumption. We need to measure energy costs, and we need to act to be able to change or to optimize those costs. So what Bertrand presented as well is how the Cisco routing technology, how can we help? And we can help at different levels. We can help at the hardware level, at the network OS level, and then ultimately at the automation level. And our next session, this session and the two next sessions, we will explain how we can help on the automation. How we can help with automation is, first of all, we want to be able to measure the energy consumption, energy KPIs. So we want to provide visibility. We want to provide insights on this. Once we are able to measure those KPIs, we want to be able to optimize. We want to optimize the network, either in real time or at least to provide recommendation on which action we should take to make sure that the network is optimized. That's in real time, once the network is up and running. But maybe what's interesting as well is to plan ahead. And what Eleni and Julia will present after me is how we can design, how we can plan an efficient, an energy-efficient network. Last but not least, we want to reduce truck rolls. We want to reduce field intervention. So we want to make sure that we provide the right tools to avoid too many truck rolls. So something like zero-touch provisioning, for example, is going to help quite a lot. I did not mention what we do at the network OS level, but of course, automation is going to leverage what we provide. It's going to leverage the telemetry, the KPIs. You will see that we have new power-saving modes on the devices. We can shut down some interfaces. We can optimize the PSU, the fans. So everything, we need to make sure that the automation platform can leverage those capabilities. So let me now jump into the CNC topic, the Crosswork Network Controller, and how it can help with energy management. So first of all, I don't know if you are all familiar with CNC, Crosswork Network Controller. So it's maybe a complex slide, but just to explain, the Crosswork Network Controller is our IP SDN controller. It has many components, many features. Some of the features that we are going to leverage for energy management are typically the element management at the bottom left. Why? Because this is where we're going to have a complete inventory of the network, including the devices, including the interfaces, the subcomponents, the PSUs. We are going to leverage the visualization. We want to see the energy KPIs on the map. We want to see graphs of the energy KPIs. We are going to leverage the dynamic traffic and network optimization eventually to make sure that we can optimize the network not only based on classical KPIs, but also on energy-related KPIs. And we want to, in the future, be able to provide some interesting closed-loop automation scenario based on energy KPIs as well. So basically, the CNC was the right tool to collect, present, and optimize those energy KPIs. So if we think about it, once again, we want to do two things with CNC. And you will see that today we do the blue part, the part on the left. And our target is, of course, to be able to deliver the green part. So what is the blue part? The blue part is about collecting the KPIs, collecting the sustainability indicators over time and keep it over time and present them. Excuse me. And of course, also to detect any anomalies, any threshold crossing for those KPIs. That's the blue part. And we want to do it at device level, which is fairly easy. But then we want to be able to aggregate at the network level and eventually at the service level. What you need to understand is that what we get from the device, so when I'm saying we are collecting KPIs, we are collecting actually technical KPIs. We are collecting temperature, we are collecting PSU load, things like that. But still, at the end, we want to be able to report against the carbon footprint, the energy cost. What you need to understand is that some information, we cannot take this information from the device directly. Carbon footprint, or energy cost, will change from one location to another. So we need to make sure that we can correlate the technical KPIs that we take from the device with some external information, if you want, that will provide for a given location the energy cost, the carbon footprint, and things like that. So there is a correlation exercise between pure technical KPIs that we get from the network and some information that come from outside. Once we have all those KPIs, both the technical KPIs and the carbon footprint and the energy cost, then it seems to be very interesting to optimize the network. And first of all, to be able to give a recommendation. So to say, oh, you are consuming too much energy in that area, maybe you should do something. What can we do? So basically, we can maybe shut down or turn up some line cards or some equipments when it makes sense, when they are not used, or on the contrary, when you have too much demand. You may want to be able to change power mode on the device, or even at the end, you could think of moving traffic from a high cost link to a greener path, if you want. So you can imagine multiple use cases once you have full visibility on the energy consumption. So if I try to summarize what we want to do across the Crosswork suite, we start from the top left in that case. So as I said, we want to collect technical KPIs. We want to store those KPIs and present them. So that the presentation or the visualization is on top right, where you want to be able to have this network level view of KPIs. You want to be able to drill down to the technical details, to the components. And this is what we are going to show during the demo, more or less. This is what we have. We have a proof of concept for this on the Crosswork Network Controller. And this is what the demo will be about. The next step, or maybe the two next steps, let's say, optimization. As I explained, this is not something we can do today, but this is something we want to do. So hopefully in 2025, we'll be able to optimize networks, or at least to give a recommendation of what we should do. So based on what we collect from the network itself, or from and with a correlation of outside information, then we will be able to provide recommendations, or even maybe to do some automatic action on the network itself. And last but not least, on the bottom left, the planning and design, where what Eleni and Julia are going to describe in details in the next session is a key activity as well. You want to be able to plan your network based on energy consumption. Just before we go to the demo, I'd like to just to give you a sense of the roadmap for the Crosswork Network Controller and the sustainability KPIs and sustainability measurement. What we are going to show in the demo is typically exactly what we describe in the CNC 7.0 POC. So we are going to provide KPIs at the PSU level, like input, output power, load, temperature. We are going to provide KPIs optical transceiver level as well, at the device level. Excuse me. You will see during the demos that we can show those KPIs on the map, or you can graph them, obviously. You can have threshold crossing alerts, things like that. What we want to do in 2025, sorry, probably mid-2025. Unfortunately, it's not fully committed yet, but we are working on having this in the product. So first of all, we want to productize this POC. So by the way, don't hesitate to talk to us after the session, give us feedback, and we would like, we like to take your feedback and integrate your feedback in the product. So what we'll do in 7.1 is really to productize this POC, making sure that we have all the KPIs, making sure that we can correlate with external data source as well. And then something which is missing from the demo, but that I will show after the demo, we are missing the dashboard. We want to provide advanced dashboard on energy KPI. That will come in 7.1 as well. And we expect to have a POC around optimization of the traffic based on energy consumption. And then on the roadmap, we have a lot of ideas. And I'm pretty sure by talking to you today, we'll get even more ideas, probably. So we want to improve the optimization piece. So making sure that you can reroute traffic based on energy KPIs, being able to shut down components or to turn on components when you need them, improve the visibility, the trending, the forecasting by doing some other level of aggregation per service, per VPN, provide some prediction on how energy is going to be consumed, detect anomalies, and then I think overall we want to improve all the closed loop scenarios that we have in mind. So making sure the system can react on any energy situation. That's what we have in mind. With that being said, I will let Sriharsha go through the demo. Over to you.
Okay. Thanks, Eric. Hello, everyone. Today, I'll be running this demo for energy-based dashboards on Crosswork Network Controller. As a part of this demonstration, we are going to showcase 4 particular things, which are going to be, one is going to be the topology map, where you can find the information related to the energy savings and the energy or the power consumption loads and those kind of things on the topology itself. And the second is, it will let you create, or like we are going to show you where you can create your policies on the dashboards. Once you create the policies, whenever there's a breach on these policies, you would get an alarm. And where can you find these alarms is the third one. And at the last, we are going to show what threshold settings you can make, or like what threshold settings you can create in order to showcase it onto the visually on your topology map. With that being said, let's get started. As you can see, this is the landing page of Crosswork Network Controller with the topology map. And on the right, you can see here, you have all the hosts, which are typically the hosts that you see on the topology map here. And then we have a power consumption tab, which typically where you can find the information related to your output power, input power, and your power supply load. The power supply load here is calculated based on the output power versus the received input power. And depending upon the color coding is done based on the threshold settings that we have put in place. And at the end of this video, I will showcase where you can set those particular settings as well. You can change, is it running?
You have to click, I guess.
I have to click.
Yeah.
Oh, OK. Let's give it a minute. So as you can see, I was just mentioning about the house and those kind of things. And then we have the power consumption tab, where you have power supply load, input power, and output power. And this is a pre-recorded demo, so I can't speed it up at this point. So let's give it a few seconds to catch up, and then I can continue with it. Yep. Yeah, now we can change the view to capture the alarms, and we can enable the alarms, and we can also look at the device settings where you can enable your power consumption metrics, where you can see these things visually represented on the topology map itself. You can customize your views the way you like, and now the next step would be to go onto the host and see what is happening at the host level. Now let's go ahead and select router R10 to get some more information about why it's complaining about, it's in red color, why is it complaining about its power supply load. So you can click on it, and you would get this detailed information about its IP address and the rest of the information. The interesting part here is, for us here today, is about the power consumption, which clearly gives you an idea about what is the power supply load, input power, and output power. You can go to history to drill down upon the graphs of CPU utilization, memory utilization, and the rest of the energy dashboards as well, like the power supply input, power supply output, and the environment, which is environment energy around the system box here. So we capture all this information and we plot it on the graphs for you guys. And you can go to detailed inventory as the next step to learn more about the interface level information that is being provided here. So you can look at the interfaces, and you can select your interface of your interest. And we are showcasing here about the history, and you can go down to the respective interface of your interest, and you can look at the input rate, output rate, if there are any discards and those kind of things. All this information is provided here. The most key information that is of our interest today here is the optical receive rate, receive power, and the optical transmit power. And we also provide you the rest of the information like the voltage, current, and power supply information here, and the temperature of the environment around it. So, so all this information is captured on the energy dashboards of CNC. The next step is to go into the device level management and create your own performance policies in order to generate alarms based on your logics. So here, I'm creating a power performance policy, which, and I'm selecting the devices of my interest, and I would hit next. I would create my power consumption policy, which is polling up to 5 minutes in a cadence of 5 minutes. And my interest here is power supply input and power supply load. So I'm creating the respective alarms based on my own values. Currently, I'm giving give me a major alarm if the input power supply is more than 300 watts, or give me a critical alarm if my power supply load is less than 10%. And if it happens one time, just give me an alarm. And the same thing I did create for optical as well. And here we are collecting this information. And I've selected the device of my interest. And the polling frequency is 5 minutes again. The next step is to find where these alarms are. They are on the alerts page under alarms and events. My interest here is to look at the device category and look at what's happening about different alarms that are being reported here. You can click on the alarm and get information about where is this alarm, what is the breach that has happened, and which policy got breached. And all this information, along with the description, is provided as a part of the alarm details. The next step would be to look at the history if you would be interested in the history of what's happening and why did this alarm got raised and those kind of things. An example for major was is also being shown here. And as you can see here in this major alarm, the power supply unit is at a certain watts, and it's more than 300 watts. So that is the reason this particular thing got triggered. The last step in this demo is to set the thresholds so that you can see this particular visualization on your screen on the topology view. You would go under topology, under administration, and then you would set your metrics. These metrics are based on the way you like. I said, give me a red color if it's between 0 and 10, green if it's between 20 and 90, and those kind of things. Those are the values that I put in. And based on these values, this particular topology is populated. And as you can see, this particular information is being reflecting here based on the settings that you would configure on the threshold settings. With that, I would like to conclude the demo and hand it over to Eric.
Thank you, Sriharsha.
Thank you, Eric.
So the goal, okay. The goal of the demo was already in 5 minutes to give you a sense of what we can do with Crosswork Network Controller today, to collect those technical KPIs, to show them on the map, to show them in graphs, set thresholds, and get alarms. As I tried to explain before, I mean, we are going to make it more sophisticated by combining KPIs from, I mean, information, let's say, coming from other source for carbon footprint and energy costs, typically. The next step as well, and unfortunately we don't have it today in the POC, is to provide dashboard, because we have all those KPIs and that we want to present. We want to aggregate those KPIs per network, per service, and things like that. So the end goal, not the end goal, I should not say that, but the next step is really to provide dashboard. If you are familiar with CNC, this is the true landing page of CNC with what we call dashlets with high-level information. We will provide a new dashlet if you want, or a few dashlets to show the energy KPI at the highest level. And then you will be able to drill down to more detailed time series information per device or top 10 device information, and so on and so forth. We have a few more examples of dashboard. If you are interested, feel free to come to us, and we can show you what we have in mind. With that being said, I'd like to conclude the presentation with a few takeaways. So today, this morning, we are talking about sustainability, so no issue. It's top of mind. It's a critical topic. I'm not sure we are going to save the planet today, but at least we try to make a better future. And when we speak sustainability, we cover, I mean, Bertrand spoke about it. It can cover multiple areas, like even packaging, product life cycle, and things like that. What we tried to do this morning was really to focus on what network automation can do today and what we will be able to do tomorrow. Because we believe it will, for us as service providers or even enterprise, network automation will play a great role to improve energy consumption and reduce energy costs. We have this first POC with Crosswork Network Controller. Eleni and Julia are going to show you the POC on way, on the planning tool as well. So we are working on this in this direction. We welcome your feedback. We have a lot of ideas, but if you have ideas, feel free to come to us and let's discuss about them. Thank you for your attention.
Thank you, Rick. Thank you, Sri. We have one question. Are there any open config sensor paths for power energy KPI? I would love to. I would love to. We try to integrate data that coming from the router. Today we're doing this with Cisco-specific path. But Cisco is not part of the open config standard. I would love that if somebody here is part of the open config standard, that talk to us and we go together and we propose something to open config. And then as soon as something is available, at least from a paper point of view, in open config, we will implement it. Then the answer is, unfortunately, not yet. We would love to have open config KPI one day. Having said that, I will present now Eleni and Sofia, both working on WAE, which is the planning tool. What we have seen up to now, it's the operation tool, but now it's what we are going to do from a planning tool point of view.
So, hi everyone. Now we're going to continue our talks about how automation can help you achieve sustainability targets. So first, let's take a step back and think about the network operation lifecycle as a whole. Sustainability should be an integral part of it. It shouldn't be an afterthought. And this is something that we've been working together with the Crosswork Automation team on. If you remember from Ran's session from yesterday, we are breaking things up into visibility, insights, and action. And we're going to talk a bit about how sustainability fits into each of those buckets. So starting first with visibility, the previous session I talked a lot about how we can provide visibility into different sustainability KPIs. And that involves collecting, storing, and also, of course, visualizing those KPIs over time. And those KPIs can be quite diverse in their own way. So yeah, you can look at power consumption of a device, you can look at carbon footprint, you can look at carbon intensity for particular sites and locations, maybe even the energy mix. Is it coal, is it hydraulic power, and so on. And of course, energy cost. Now, once we have access to all of this data, all of this information, we can analyze it in order to gain meaningful and hopefully also actionable insights. So we can we don't want to look at metrics like power consumption just on their own. We want to also understand the context. So if we look at a particular device and we measure the power consumption, so what does that mean? What capacity does this device provide? So then we can derive more composite metrics and say things like, hey, it consumes this much power per gigabit per second of installed capacity. And then comes the usage. So, okay, you have all of this capacity that is installed, but are you actually using it? What traffic is being carried by that device? So then you can think of how many watts per gigabit per second of carried traffic, to give some examples. And of course, not looking just at the device level, you can look at the path level. So you can say, hey, what is the power consumption per segment routing policy? Or even what is the carbon footprint per VPN? And the next session we'll talk to that a bit. And then it's also possible to do some analysis and understand if there is any anomalies in terms of sustainability KPIs. So is there a significant deviation for the power consumption of a device compared to its past or compared to other similar devices? And then finally, of course, which will be more the focus of this session, how can we design more energy efficient networks? And that, more on that in a bit. So looking at the action part, Eric gave some examples as to what optimization objectives can be set and what are the levers in order to be able to achieve those objectives. So very quickly, one example is the ability to selectively shut down a set of components based on observed usage patterns. Or maybe change the power and performance modes. A hint, we'll be looking at that in this session a bit more. And then finally, moving services onto greener pastures. I have to make that joke, greener paths. So let's zoom in a bit on network design and planning. So in order to operate efficient networks, you need to have the right foundation. And that foundation comes from having properly designed and planned them in the first place. So in order to do that, you have to be able to answer a bunch of hypothetical questions. So it's things like, what would happen if my traffic grew by 10%? What would be the impact? What would happen if any link were to fail? What would happen to the utilization? So once you are able to answer those questions, and in order to do that, you need some form of simulation engine to be able to actually understand the impact of things that are not happening at this moment, but may happen in the future. So once you have that foundation, then you're able to actually optimize your network design and planning. So typically, objectives would be minimize the network equipment capital expenditures as you're looking at your future plans. And for that, you can impose a set of optimization constraints, like I don't want the utilization in my network to exceed 50% under steady state and 80% under any single link failure. So constraints like that, maybe some things on performance, like bounds on end-to-end latency. And then looking at sustainability, we can additionally introduce sustainability objectives. And I think a key word here is additionally. So it doesn't have to be either or, but we're able to also evaluate such constraints and objectives and then evaluate potential trade-offs or actually even synergies in a lot of cases. So looking at projected traffic growth, you can say, what would be the power consumption or the carbon footprint in order for me to meet that growth? And then what type of equipment should I actually select to optimize that? There were quite a few mentions of the routed optical network architecture today, so I think it's very interesting to think about benefits of optical pluggables also compared to transponders in terms of power consumption. So analysis like that, or you want to deploy a new site and you want to find the optimal location. So maybe some locations are served by different energy sources. But in order to be able to do that analysis, you need the right tooling. Enter Way. As probably quite a few of you here know, Way is an industry-leading planning tool. It has been around for many, many years, and it came to Cisco through the Caradan acquisition. So how does it work? So first of all, it needs to build an abstracted network model instance. So that contains the information on the topology, information on things like segment routing policies, RSVP LSPs, abstracted VPNs, even optical layer information. And of course, a key ingredient to it is what we call traffic demands. So these represent the end-to-end traffic flows. So we need to see what that is in order to then be able to simulate how traffic would reroute under different scenarios. So then at the bottom, you see a visualization of a topology and then the sets of functionality that it offers on a high level. So of course, you can visualize, you can simulate different scenarios, you can analyze the impact under defined sets of failure scenarios and then see what would happen. You could do capacity planning, and then you can figure out where you should add capacity to meet those constraints while minimizing costs, for example. And then finally, a set of optimization tools, things like IGP metric optimization, segment routing path optimization, and so on. So the beauty of Way, in my eyes at least, is its extensibility. So at the top, you see how you can create a new LSP through the GUI. But you don't need to do it through the GUI. You could also write a script. So we do have a very rich set of APIs. The lower level is what is the RPC API, and then we have a higher level API, what we call the OPM API, which is more Pythonic. And then it allows you to write your own scripts and do whatever you want. And this is something that we've done in this POC, and Julia will talk about that a bit more. And another key part is that, of course, we have our schema that defines the attributes and the objects that we understand and we simulate, but you're not confined to that. You can actually go and extend that schema so you can have user-defined attributes and user-defined objects as well. Yeah. So going back to sustainability, in order to be able to achieve sustainability goals, you would typically ask a series of questions. So first of all, how can I reduce the energy consumption in my network? What would be the recommendations? And then once we have those recommendations, like if I went ahead and made those changes, what would be the impact? Because it's not only about sustainability, there are other aspects in play here as well. And then finally, assuming that I do want to go ahead with that, what steps should I follow to actually go ahead and provision those recommendations? So in this POC, in a bit, we are going to be using Way, some add-ons, so the custom extensions that we spoke about a bit more, and also Crosswork Workflow Manager together with NSO. And maybe you saw some of the Crosswork Workflow Manager sessions earlier. I think there are also some following. So with that, let's jump to the demo, and I'll hand it off to Julia.
Thank you, Eleni. Okay, so my name is Julia. I am TME for Crosswork Automation, and in this demonstration, we want to show an early prototype of a closed-loop automation solution for sustainability. And what we want to show is how our applications, our Crosswork applications, can interact between each other to provide this objective. So starting with the demonstration here, we can see that CNC already collected the network topology information as well as all the traffic engineering information. And CNC provides a RESTconf API to export this network information into a network model format that is understandable by Way. So if we go to Way, we can see the representation of the same network model, including nodes information, LSPs information. And here we also populated the demands that represent the traffic that is routed throughout the network. So then if we go to the nodes table, notice that it is important to collect the vendor, model, and OS information, because this information will be used to identify which devices support the power profile capability. And Way provides a large set of Python-based APIs to create extended functions that are also called add-ons. And this is how we build this power-saving add-on. So it includes 3 steps. The first step is the recommendations. And here, the tool will provide to the operator some energy savings recommendations based on the current actual network model information. So once this first step is executed, it will produce a new plan file. And in this plan file, it will also create a new table. So we will open this new table. It is called Sustainability and Device Capabilities. And in this table, the operator will be able to see the mapping between the vendor, model, OS information, and the capabilities of support for sustainability. So in this case, the tool identified 2 specific device models that support the NPU power profile, and the recommended value it is to set to low. It also provides a short description on why this low value is important. And if we go back to the nodes table and open the corresponding vendor, model, and OS columns, we will see that the tool also did a match of this information with the device capabilities table and identified that one device in this topology, the R13, supports the NPU power profile. And actually, its value is set to high, which is a not recommended value. So then the add-on will also generate a report. This report is called Power Saving, and it will include the recommendation summary, where it identifies that one device is using a non-optimal energy management setting. And in the details table, it provides the details of this device, including its current value and the recommended value that should be set to low. So then we also can monitor in CNC what is the current power consumption for this device that is using the high profile. So we can see that it is consuming 254 watts for the input power and 204 watts for the output power. So next, because in order to change the power profile, it will be required to do a reload of the device. So the operator may be interested in seeing what will happen to the network, what will be the impact during this reload. So in this model, we can help to identify what demands are used in this device. So we can see that 2 demands are routed through the R13. And if we filter to the corresponding LSPs, it finds 2 SR policies that are associated to those demands and are routed through the R13. And this information can also be validated in the CNC. If we go to the TE dashboard in the CNC, and we select the two SR policies, and then visualize the IGP path for them, we can confirm that they are routed through the R13. So then back into Way, we will ask Way to do this simulation. So for that, we will execute the second step in the add-on, that is the impact analysis simulation. And here we can set a maximum interface utilization, for example, 75%, which means that during the simulation, if any interface goes above that threshold, it will be considered a violation. So then after the second step is executed, it will produce a new plan file. And in this plan file, we can see that traffic was already drained out from this device because it was put into maintenance or avoid transit mode. And if we check our two demands, so we can see what happened to them. They are still routed, but they are using a different path. Now they are going through the R6. And if we filter to the corresponding LSPs, we can see that two SR policies are still active and routed, and they are using the path through the R6. And also all the links are showing green color, what means that utilization is lower than 50% in this setup. So this second step will also produce a new entry in the report, that is the impact analysis summary. And it is showing that 0 interfaces are crossing the threshold that we set to 75% of utilization, and also 0 LSPs are unrouted in this network model. So then if the operator is comfortable with these results, the next step would be to do the provisioning, so the actual changing of the power profile. And for that, we will execute the third step in the add-on, that is the deployer. And here, the tool will communicate with a workflow manager via RESTconf API, and will pass as an input argument the name of the device that was identified in the previous step, in the recommendations step. So once this add-on is executed, it will trigger the workflow in the workflow manager. So let's switch now to the workflow manager UI. And here, if we do a refresh, we will validate that the workflow was triggered, and it's running, and the first step in the workflow is already completed. So that means that the device was already put into maintenance mode, and we can validate this in the TE dashboard in CNC. If we show the IGP path for the two SR policies, we can see that they are using the path through R6, which means that behavior is exactly what was predicted by Way. So then we need to wait for the next step to be executed in the workflow, that in this case, it is to change the power profile to the low value. So we can see that it is running. If we do a refresh again, we can see that the step is completed, and the next step in the workflow is to execute the reload of the device. So we can also validate this in CNC, in the topology UI, that the device is being reloaded, because we can see, for example, in this case, the links are showing degraded or down state. And in this setup, the reload of this device will take approximately 5 minutes. So we can monitor the progress of this task through the workflow manager. And once it is completed, we can see the links are back to healthy state in the topology UI. So after that, we still need for the additional steps in the workflow. So if we click refresh, we can see that the device is now removed from the maintenance mode in order to permit, again, that the traffic goes through its device. So in this case, if we validate in the TE dashboard and select our two SR policies and visualize the IGP path, we can see that they are now using, again, the original path through the R13. So next, we just ensure in the workflow that all steps are completed. So we validate all steps in the workflow are completed. And then that means that the power profile was successfully set to a low profile. So we validate in the power consumption dashboard. We wait for the next collection period, and we can see that the power was decreased. The input power is now 212 watts, and the output power is now 152 watts. So it means that in average, it decreased around 50 watts for this device after we changed it to the low power profile. So with that, we completed the demonstration, and now back to Eleni.
Thank you, Julia. So this is the last slide, don't worry. So summing up, we showed how automation can help you achieve sustainability goals using some of our products and extensions. And at the bottom, you see the degree of automation increasing with increasing automation towards the right. So you can think of it as a journey. You don't need to do everything all at once, but there are some steps that can be taken. So for example, here, the first step, you can see that there is some analysis in that respect, but a lot of it is manual, and you see a lot of user interactions with the way side. But then you could and there's a separation with respect to how those recommended changes are provisioned. Here now we're automating all of these manual back and forth through a script by having a way add-on, but there's still no integration with workflow provisioning aspects. And then finally, you could have a more holistic approach where everything is more integrated and both the analysis and optimization is automated, and also there's integration provided with the workflow. So thank you very much for your attention. We're looking forward to hearing questions from your side, and also please do reach out afterwards if you'd like to discuss any sustainability aspects. So thank you.
Thank you, Eleni. Thank you. Let me introduce Monica. She's going to talk about network or service assurance. And to me, that is super important. Imagine that you are an enterprise and you want to reach the scope 3 net zero strategy. What's going to happen is that when you rent a service, you buy a service from service provider, the first question you're going to say, for my business VPN, how much carbon that will be produced by me in your network? And that's a big question. And she will answer to that one during this presentation.
Okay, so as we were talking about sustainability, I will be talking about three main concepts during my presentation. One is like how Accidian Skylight, it's a very powerful network service assurance tool, how sustainability can be part of this assurance, a new way of just looking at the assurance as well, and how we can leverage the automation with all these, putting all this together. So, Skylight. I think we were just talking during previous sessions about this, but basically what we are doing is providing this information on how the service, the end-to-end service, is performing. And it all starts with the data. So the data is what it's giving us this visibility. So we collect this end-to-end service assurance with our sensors, and we do it in a way that the information we collect is we are just providing this full visibility. We can monitor literally any flow, any service over the full network. And we do it with, we collect very good data. And that's important. The good data is what gives you the right visibility. If you are just not doing you don't have the right resolution, you don't have the right granularity, you are going to be missing a lot of information. So this is what we do with our Skylight sensors. And we are collecting all this data, and okay, you can have many data points, a lot of information, but if you are not able to extract meaningful information out of that, it's useless, basically. So that's why we have our Skylight analytics in the picture. So we are just ingesting all this data, and we extract meaningful information out of that. And with that, we provide this end-to-end visibility over its multi-vendor. That's important as well. We don't want to be restricted only to Cisco devices or Cisco parts of the network, and also multi-domain. And on top of that, it's like the action part. The action could be something as simple as just be able to understand out of this data just with a few clicks, just to understand what's going on, if there is any issue, what's going wrong. Also, because we can detect anomalies, we are able to see if there is any like if things are going wrong, act on that. So for that, we are leveraging our integrations with the automation, Cisco Automation platforms, with CNC and with NSO. And also, it could be also something like generate new revenue, and we can do that with our end customer portal. And tomorrow there will be a session about that with more details. But it's I was talking about the data and how important it is, but also how important it is to have the right tool to extract meaningful information. And we do that with our performance analytics. And the way we do it, we ingest the data there, we add contextual information, and the contextual information, it can be different depending on the customer, so we are using for that metadata that it's fully flexible. So the customer can choose which metadata they want to use on the system. So we use all this metadata to do correlation, to do, we can do proactive alerting, but also based on this context as well. So, and in analytics, what we are doing is like, because we are doing that continuously, we get the data continuously, we build this statistical model of the network, so we can detect anomalies, we can detect trends, we can look at how things are happening, and also it could be used for reporting, for analysis, for a lot of things. And also we can ingest not only our data, but also third-party data, I mean, that data from any source. And also we have all these open APIs that allow us to integrate into like the automation system. And that's also an important part of the solution, because then, you know, when you create a new service, in the past, the service was created, then it was handed over to a different team that was just creating the assurance on that. There was a gap. So now we can do that immediately. So at the same time we create the service, we add the assurance. It could be with NSO, it could be with CNC, and then the assurance is part of the service lifecycle. And on top of that, we can enable the automation capabilities, because we provide information on how the system, the services are performing. So we can just feed up to the orchestrator, like alerts. We can feed KPIs, so the orchestration can take the right decisions, right? So now I'm going to be talking about sustainability. How does it? I mean, what does it have to do sustainability with all these assurance things? So basically, we are doing sustainability. We are adding it as an additional KPI, the same as the rest of the assurance information, like latency, packet loss, all these. And it's not something we just made up. It's because we had customers using the assurance solution that were interested in getting this information. And not only for internal purposes, but also they wanted to be able to show that to their end customers, expose this information to their end customers. And the way we build this with them, there are like 3 components, right, to the solution. So one is a Skylight platform, of course. Then we are using also NSO to do all the provisioning, all the automation. And then there is this new component, which is the sustainability app. And the sustainability app is providing us the information, like the performance info, the sustainability KPIs, like power, carbon footprint, efficiency, all this. The way it works, and we were working with an innovation team in Cisco just to be able to build this sustainability app. There are like different inputs into that. So one of them, of course, and it's been like in talks just before me, is electricity maps. So we need to understand if, to be able to derive like the carbon footprint, we need to understand what's the source of this energy. So if it's more like coming from oil, it will be different than if it's coming from like solar or any other sources. So that's one of the inputs that we are using. The other one is we need to understand, because we are exposing this not only by device, but also by service, we need to understand what's the path the service is taking, and we are taking that from the network. And also we need to understand, I mean, we know the path, but we need to understand what are the devices that the path is traversing, so we can also know, we need to know also how much power they are consuming. And then we are just, you know, the innovation team is like just doing all this calculation, and then we get these KPIs at the end, which is like things like power per service, carbon footprint per service. And then we can just display that into analytics in the Skylight platform, together with other assurance KPIs. So that's why we say sustainability as a KPI, as an additional assurance KPI, because now we can see if a path how much power it's consuming by service, how much carbon footprint, and we can display that together with things like latency, for example. So now that we are exposing this information per service, we can also use this as the same as we will do with latency. For example, if you have a lower latency path, probably you will want to switch your service to that lower latency. So we can do the same with power, actually, or with carbon footprint. So we can just use it as an additional KPI. And this is what our customers want to do. And this is where all this integration with NSO comes together. So all the three components of the solution. So now we are able to, in our analytics platform, we can show visibility, we can provide visibility of sustainability KPIs over time in different dashboards. We, by combining these traditional service assurance KPIs with these sustainability KPIs, we can give the choice to users to decide, okay, I might take a different path, a different service path that it's consuming less power, or it's like more optimal in terms of carbon footprint, even if it adds a little bit more of delay to my end-to-end service, but it's still under the SLA. So you have the choice to be able to do that. That's why we say it's like it provides greater insights than the combination of all these KPIs together. And also, we can, at the end of the day, you can make also this available to end customers using the out-of-the-box capability of customer portal that we have in analytics as well. So this is some examples of how we can expose the information in dashboards. Our dashboards are fully flexible. You can build your own dashboards with the information, and then you can add more additional information, like contextual information, like per region, per service, per customer, etc. And this is an example of a customer portal where we can expose not only the SLAs to the end customer, but also we can expose things like carbon intensity as well. So, and yeah, at the end of the day, what we can do with that is provide additional new services to the end customers. So this could be something that they can expose, they can make their own customers decide if they want to take different paths that are more like sustainable. It's also a way of demonstrating power carbon footprint reduction, because you have all the visibility. You can just create reports. You can just see efficiencies. You can just organize the data as you want in our analytics platform. And also, you can use it to detect abnormal trends, because we are doing that over time. This is using the same capabilities our traditional assurance information. So detect anomalies. We can set up thresholds based on baselining, all these kind of things. And also we can benefit from the integration of Skylight with the automation platforms with NSO CNC. And yeah, I'm just going to be jumping into a quick demo where we use NSO to create a new service between two endpoints. So this is like showing how we create the new service. So it's all fully following all the life cycles. So this is creating the configuration on both routers, both ends. So in this case, it's a lab in Italy where we have two sensors on both sides of the routers where we are creating the service. We are adding the assurance at the same time with NSO. And then, yeah, well, this is the information that the configuration. So this is the configuration for the Skylight. So we are adding a TWAM session. We are adding metadata. This is the contextual information that I was mentioning before. And then we send this into like the routers for the service, the Skylight configuration for the assurance. And then once this is done, it will just create the TWAM session. So this is how it's showing how the new T1 session is created in our system. It will show the parameters of the session. The T1 session is the assurance session with all the information, how many packets per second, collecting the data, and then we can go into the inventory. This is the metadata. This is the contextual information. So it could be anything that it's important for the customer, and then we will be using that in all the analytics platform. And this is once the session is created, the service is created, we start monitoring it. We start to get information, SLA information, and then in this case we are creating the service we were creating was over a specific policy, which is like the 232, which is going between Ischia and Ercolano. It's like, logically, it's the more direct path. But if you look at the sustainable, at the power, carbon footprint information, there is an alternative, which is going through policy 231, which is not the most direct path. But we can automate that in a way that this information is uploaded into NSO. So the next step will be, okay, maybe I want to switch this service onto the new policy 231. And then I will be using NSO. This is now doing, we are doing that manually, but it could be automated, of course, like sending an alert or sending the KPI into NSO saying, okay, I want to go through this new policy, which is more sustainable, right? And this is something you can automate. It could be a closed loop. And it's doing the changes. NSO is doing the changes. So we see now that the new service ID is using the new policy. We are starting to visualize the data in analytics. And what we see, actually, is when we make the change, actually, the latency is lower than before, even though it's not taking, because the end-to-end service, even though it's taking a longer path logically on the map, basically what we are seeing is the latency is lower, so it's even better. But if it was the other way around, let's say that, for example, your latency is increasing a little bit, you can take the decision to still keep it, even if it's a little bit more, a few more microseconds or milliseconds, as long as within the SLAs, right? So this is a decision you can take now because you have the visibility. And then on the last part of the demo, I'm just showing some of the other analytics capabilities where we can just show this. This is dashboards that we can customize. You can expose that. You can go back in time. So you can go back in time 1 year. So you can see the trends, how your KPIs are evolving. And also, this is the customer portal where we are exposing. On the customer portal, you will have full visibility over all your customers, and we are using the metadata for that, and then you can expose as well carbon intensity as well to the end customer. So that could just be another additional service that you are providing to them. So that's my presentation. So I hope now you understand why I was talking about why Skylight is a powerful network service assurance tool, also how sustainability can be an additional assurance KPI, and also how we can just leverage the automation integrations of Skylight with NSO and eventually with CNC as well. So that's all.
We're going to have a break now, 10 minutes. We are a little bit late, then I will ask you to not take more than 10 minutes. And we will start it is 10:15, we will start at 10:25. 10:30, excuse me, 10:30. And we will start with networking assurance. That will be the next sujet.
myself down to the bottom. There is no place to hide and no one can call me. My name is so dirty, call me dirty girl. You made me a sinner, so I'm on my own. Falling apart, no stopping to lose. I'm clumsy and not you call me a loser. La 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 la. La 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 la. La 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 la. I swear you can call me a loser. La 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 la. La 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 la. La 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 la. I swear you can call me a loser. I swear you can call me a loser. La 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 la. La 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 la. La 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 la. I swear you can call me a loser. My name is so dirty, call me dirty girl. You made me a sinner, so I'm on my own. Falling apart, no stopping to lose. I'm clumsy and not you call me a loser. La 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 la. La 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 la. La 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 la. I swear you can call me a loser. La 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 la. La 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 la.
Cisco systems breaking through the scene. With Ethernet's power, their victories foreseen. Whoa, wired for success. Cisco's got the edge, they're outperforming the rest.
I guess we are introducing ourselves, Eric.
Yes.
So we were supposed actually to have this session after Clarence's session. We gave an hard time to Niklas. So I'm Paola Rosio. I'm a Director of Product Manager in Cisco Networking.
Yeah, and I'm Henrik Nydell, part of the product management team for Axelian Skylight. So let's get started, Paola.
Yeah, let's speak about network automation and assurance. So I'm starting with those numbers, right? Some of the numbers come from a first research. First number, 80%. 80% is the time that is spent to understand where the problem is. What we call mean time to identify, mean time to know, also called mean time to innocence. So it's my fault, it's your fault, where is the problem, and so on, right? 74% is the number of time that a customer finds an issue before the tool that we actually have, the service provider have. And 30% is like the time that an issue is a repetitive issue. What they are impacting? Those are impacting, the first one is like the visibility, the agility to actually introduce new technology. The second is impacting, of course, customer experience. And the third one, the productivity of the team. So let's actually look at the experience, right, that we have based on those numbers. The customer finds an issue before the tool, and then it says, well, I actually have this problem. I call the help desk, and the help desk has no visibility of what is happening. So maybe it's a new technology, and so they are actually escalating to the next level. The next level, it's looking, where is the problem, where is the problem? We need a subject matter expert. The subject matter expert actually is involved, so he cannot actually focus on innovation, but he needs actually to start troubleshooting, right? And troubleshooting a service, it means like to look at different aspects of this service. So some of you are actually, most of you are familiar with NSO and the beauty of automation. The very first things actually that you need to do to automate is to model. You need to model what you want to automate. So let's think about how we can actually model all these steps so that all these troubleshooting steps can be automated. This was like already presented yesterday by Rana, so I won't spend a lot of time. Our goal is not actually to have the same functionality in all the levels. It's like present the data in a way that can be consumed by the operator based on the information that they have, the knowledge that they have. The level 1 operator, we don't actually have the deep expertise in the technology that the subject matter expert has, and they need to actually have different tools. So this is why we actually have assurance capability that are delivered by Skylight Analytics. We have assurance capability in the hierarchical controller to help the operator to identify where the problem is on the IP or on the optical. And we actually have deep assurance capability into the controller to help the operator, the subject matter expert, to get that visibility needed to troubleshoot a problem. And with that...
Thank you, Paula. If you were here yesterday, there was a quote from Lord Kelvin about that what you cannot measure, you cannot improve. And this is, of course, again, reiterating the meaning that it's very important to be able to get KPIs and to get more information about how your network performs. So this is why we built Accidian Skylight, started 6 years ago building this platform. The idea of taking in as much as possible of various types of metrics into one platform and be able to combine them together, to correlate, to find anomalies, to find patterns in the data. So when you look at a Skylight dashboard like this, it may look like it's only one single metric you're looking at, but in fact, it could be a fully aggregated network view of thousands and thousands and tens of thousands of metrics that boil up into a single line showing the full health or the worst offenders, like a top-end list of data metrics. So to do this, we of course need to instrument the network. And we talked about this yesterday. I'm going to go into a little bit more detail. So the type of various sensors that we have at Accidian, now part of Cisco, range from software-based, containerized, virtual machines, small form factor pluggable, but also larger probes that are rack mountable. We call them the performance elements. We also actually have capture sensors that can look at customer data and do real-time analysis of the applications that flow in the network. But this is not enough. We want to get more data into Skylight. So this is why we also built an open ingestion pipeline into the solution, so that we can take third-party KPIs from other vendors and other products. But now also together with Cisco, we have started integrating with the Cisco platforms to get more KPIs out of the install base. But to look at the whole family of Cisco products that we sort of try to tie together in the Skylight solution, we have on the left-hand side CNC, NSO, HCO. So the past year we have worked on the integration with these platforms to allow communication both ways. So the orchestration tools in the Crosswork platform can communicate with Skylight, set up our tests, configure our sensors, and can also retrieve the data back. We can get notifications if something changes in Skylight, but also get the full data feed or select data points back into CNC. On the northbound integration side, we are working with Thousand Eyes, we're working with AppD, and with Splunk. This is still prototype development, but we want, of course, be able to provide our alerts, our insights of what happens in the service, in the network, up to those platforms. But finally, looping back to our open ingestion pipeline. So if you look at the blue box in the middle, that's where we are investing heavily right now to be able to take in SRPM data from MPLS SR environments. We are working with, as Clarence mentioned yesterday, with the new IPM initiative on getting those data points in. Routed optical networks, model-driven telemetry from Cisco devices, as well as the sustainability metrics that Monica talked to you about before the break. So with the width of those metrics, there are at least three. I'm going to talk about 3 use cases today that we are working. So one is the SRPM, where we take in the hop-by-hop statistics from a Cisco SRPM network and correlate that with an Accidian end-to-end view that monitors on the top. Sustainability, I'm going to double-click quick on that because you heard it before the break, but getting the KPIs from devices that can report power consumption, etc. And for routed optical networks, it's a very interesting use case to be able to take in optical metrics like receive power, bit error rates, etc., and correlate it with the higher layers of assurance that we can do with Skylight. So why why is Skylight so good, right? One reason is because we have built the solution ground up to be very accurate, very granular, and provide a wealth of metrics that are not only min-max averages. We report, I think it's 10 or 15 various percentiles of distribution of delay and jitter values. We can report report one-way data, so not only round-trip values. We can divide the data on uplink and downlink and show that separately. And one important point is granularity of the metrics. So Clarence yesterday, who talked about IPM, he talked about how important it is to monitor the network often, but it's also important to report the data frequently and often. So traditional systems may do just an average report every minute, and you may think that your service is performing well, that it's below the threshold of 2 milliseconds. But if you have a solution that can report more in a more granular fashion, you may see that you are actually breaching the threshold now and then, but you wouldn't see that if you wouldn't have the higher granularity that we can provide with our solution. So with that, I'll go over to a quick demo showing how we are looking at various services in the Skylight platform. On the top layer, we have our latency measurements using TWAMP. We can see here there is some packet loss events happening periodically. So, and this is an aggregated view of the full network. So it's a full customer, all the monitor session for a single customer. We can zoom in on a particular event. And when looking at that event of a packet loss, we can see that it looks like it correlates between various measurement sessions. They have the same pattern in the middle column. So going over to our pattern analysis mechanism, you can now see that it's the router in the middle that is orange, that is the common point between these measurement sessions. And that's the common point that is contributing to this issue we were seeing then periodically happening. That's a way of using Skylight to troubleshoot and actually try to find the culprit or the actual reason for an issue. Looking at the different use case, here we have a packet loss that is 100%. So everything is gone during a short period of time. Looking at metrics then from the routed optical network side, we can see that this event correlates perfectly in time with that there was a dip in receive power for the optics. So we can come to the conclusion that, yeah, something happened with the fiber. That was the reason for this end-to-end service to have an issue. Here I show a graph of our ongoing integration with SRPM. So we're also taking in that data, displaying it in the same type of dashboards in Skylight, and can correlate the data with all the other types of KPIs that we can ingest. So with that, I will hand over back to Paula to tell how we work more together with CNC.
So, as we said, like, we need to present the data in a way that are actually consumable by the operator. So the operator that is looking at Skylight Analytics may not actually have all that deep knowledge on the topology, the traffic engineering, and so on, right? But he needs actually to understand it's my service meeting the policy, the SLA, or there is like a risk of breach, and so my customer is going to be impacted. Then, the next level of operation, like Rana was telling yesterday, we need actually to help the operator in understanding in which domain there is a problem. And the approach is always top-down. I start from the service, and that is one of the reasons of the acquisition of Accidian, which is the quickest way to actually understand if the service is degrading, is testing the service, empirically testing the service and understand if it's actually dead down. Then, once I actually have a service impact, I want to look where the problem is, right? And this is like if you actually have a multi-layer network with packet optical multi-vendor network, then you want to understand if the problem is rising because you actually have a problem on the IP part or a problem on the optical part, or the two are in some way related. So you can actually activate the proper subject matter expert of the specific domain. So here it's like just an example of some of the functionality that has been added in HCO. HCO is like the core functionality that HCO provides is the visibility of the topology across the different layers. And then we are using this topology visibility to enable some assurance use case. One of these use cases here you see is the link assurance use case that help you in understanding across the different link of the optical layer that are connecting the ZR optic that are actually running on the router where the actual problem is. And in order to do that is actually presenting the data that are actually related to that specific link, always collecting data and contextualize before visualizing so that the operator that actually use that can actually understand. The same approach, we are doing that for the Crosswork Network Controller. In the Crosswork Network Controller is our IP controller. Also in the IP layer, you actually have different layers. You have the infrastructure, you have the traffic engineer, you have the service, and you can actually go, it's like about slicing, transport slicing. So how we actually approach that? We are actually looking at the specific metric that identify the health of each layer, right? At the infrastructure, we are collecting, fault, specific API, not everything. We don't want to flood the operator with a bunch of KPI. We are collecting the one that we know that can actually influence the health of the component in the infrastructure. And the component infrastructure are interfaces, port, pluggable, module, device, and the link that connect the different devices. At the next level, we are leveraging the instrumentation that has been added on the XR, and we are leveraging the SRPM, that is, at the end, a TWAMP-based tool. At the next level, again, we are actually leveraging Accidian, because Accidian gives us actually the possibility to enable probing on device that does not support standard TWAMP testing. And remember that Crosswork Network Controller is a multi-vendor application, so we need actually to be able to enable also third-party device with probing. But then we are actually leveraging on a concept that has been actually introduced in ITF and now is in RFC, that is called Service Assurance for Intent-Based Networking. I will go a bit deeper on this concept because it's very similar. There is a lot of parallelism with the concept of a network service orchestrator. And then, of course, because we can monitor a service, then we can monitor also a transport slide that is actually mapped to a service. So here it's like some small view of what we can do, right? So again, we can actually give a complete visibility to the operator where the problem is by actually providing the visibility of the connectivity. I have this interface on this specific port, on this specific card, on this specific slot, on this specific device, and so on. Always contextualize the information. I can provide also fault information and actually overlay that on top of the inventory. And in 7.0 that is coming out in August, we add also all the metrics. Some of them you have seen during the demo of the sustainability. Of course, we can actually generate a threshold crossing alert that actually can be consumed. At the policy level, we use the SRPM to actually have two levels of monitoring. One is on the link, on the core link, because Bertrand told me, right, that most of the time, if you actually have a service degradation, it's because one of your core link is actually impacted or is degrading, right? And so we actually use that, the SRPM for the link monitoring. We are not collecting the quantity of data that can be actually provided by Accidian. We collect, some data because our goal in the context of the controller is to understand where is the problem and help the operator in the troubleshooting. And then we are using SRPM. Of course, when there is like a policy associated, we can actually measure the health of the policy. Of course, we can actually expose this information to the next level. Then, in the context of Accidian, what we have done, we actually have done an integration very similar to what you have seen yesterday with Eric and Niels on NSO. What we are doing is like Crosswork, is like interacting with the Accidian orchestrator, like it's interacting with any other node, right? So we are actually asking Accidian, I want to actually have a session from here to there. Crosswork does not know where the probe are, if there are virtual probe or if it is NSFP. It's actually using a REST interface to provide some of information. And our intent is like to extend, so you can actually program which type of test you want to run and which type of information you want actually to receive. During this programming, what we actually provide to Accidian is like, we provide also the service on which we want to actually have this session enabled, and the topology where we want to actually have this session enabled. And all these topology and information are described in the Young model of the service definition that is done in the function pack for NSO. And then when we receive the data with the frequency that we actually have defined, we receive the data already contextualized with the service information that we pass. And that service information can actually be used as metadata to enrich the view into the Skylight analytics. How that are the different components. Then we need actually to put that together. And that is like where it's come, the service health. The service health is an implementation of the ITF RFC 9417. How the service health work? We were saying at the beginning, think about you can model all the troubleshooting steps that you will do normally in a definition, in a model, in a specific language. So like I'm defining in the function pack how I want actually to provision a service, I have also a companion of the function pack in the assurance that is called a heuristic package. In the heuristic package, I'm defining how I want actually to monitor the different components. Which are those components that I'm going to monitor? Are exactly the component that I can actually deriving from the definition of the service on NSO and the configuration that I have on the device. So you will see that in this specific example, I'm monitoring a layer 2 VPN. If there is like a configuration of the probe, like in this case, it's an embedded probe Y7031, then I will see that branch. If that configuration is not there from the service, you won't see that branch. So this graph model is completely dynamic and is changing as the service is changed through NSO. Of course, then we want to present the data to the operator in a way that is like consumable. So we are actually presenting the same graph to the operator. One other thing that we are doing, each component of this graph is actually assured independently, and we are actually providing also some hint to the operator on the cause of the degradation. So the operator won't need actually to drill down and understand exactly where is like the problem. He will actually have a view of the problem, but also a hint of the possible symptom. And of course, we can actually expose all this information. I mean, Farouk will actually have a session tomorrow about that. Just a small demo. They're like very simple. Here you see, as always, crossword network controller. You see, the information, which are actually the data, the service that are degrading. I can actually go select the specific, unselect and see which one that are monitored and not monitored. I can choose which one actually to monitor. And I can choose the type of monitoring. So we use advanced if we want actually to enable also probing with Accidian on layer 3 VPN services. So I can actually go into the detail. If you see here, it's like already I give some information, and I give also a possible reason of the degradation of the service. So I don't really need to go down into the detail of the reason why. I already actually have a hint for the operator on the possible reason. In this case, you see that there are actually 3 sessions that actually has been actually defined, and it's been completely automatic. So once the operator enables the monitoring, they can see they actually have interacted with Accidian to get the information. This is like a more deeper representation, right, of my model with the different components. Again, I see the 3 probe sessions that has been created with the one that are actually impacted. One other thing that I can do, I can, of course, actually review, which is like the detail of the symptom that I have, but I can go back in time and understand if the symptom that I see now, it's like similar to a symptom that I actually have in the past. Whenever there is a degradation, the system actually collects data for 24 hours and keep collecting data till the degradation has gone. So I can always compare and review those data. The second one that you show is like exactly data that are coming from the session that has been actually created through Accidian. I believe this is last slide. So how the operator experience change. We have seen at the beginning, right, that there was like a ball rolling down to the domain expert. In this case, we actually have each operator, even the customer, actually have complete visibility of the service that they have in the network in a form that is like more aligned to their knowledge and what they need actually to know. So the customer to Accidian can actually have a customer portal and they can monitor their services. So they can say, well, I actually see a degradation, and I saw that in the dashboard that I have that. You know, the first level, let's say, it will actually have a view of, yeah, I see my service, I see also that they have a degradation there, and they actually have an hint on the possible reason. It's like, yes, the device supporting YORP is dropping packet, and then, you know, you can actually have the level 2 and level 3 at this point. They are not needed actually to continue to support level 1 that actually have more information about the service, but they can actually extend the heuristic package. How you can extend the function pack of NSO, you can do the same thing with the heuristic package. So do the development, develop new use cases that you are seeing in the network, and then actually publish the heuristic package that can be consumed, so you will actually enable your level 1 and your front desk to be more independent and leave you alone to do innovation. So I don't know, I believe that we were a quick speaker, Niklas, and we recovered time.
Yeah.
So with that.
Yeah, thank you.
Any question?
Yeah, so, and just one last, at 1:30 we are opening up a demo station in one of the rooms upstairs. I think it's the Sun Dragon. So feel free to drop by if you want to discuss your use cases and see how Skylight works. I'm going to be there. Okay.
And if you have questions, I'm actually available, and we have other session, right, more going into the detail. Thank you, Kay.
Thank you. I will invite Tri and Victoria. They're going to talk about NSO. We're completely shifting gear here. NSO, current and future innovation.
Okay, hi. First, an apology. The title is slightly misleading because we are going to talk about the past and the present. I don't know how we thought this out. Hope it's interesting anyhow. The thing is that NSO is what we call a mature product. We avoid old. And with that, the architecture is also old. It behaves well, but some things we can't do, and we try to understand how we can improve that. So for that, we have something like an research initiative, and that's not like an academic research. We just try out stuff that we don't know if it will work. And we've been doing that for a couple of years. So, then what are then research topics? What's difference with features that we do? The biggest one is that it must be something that we can't do today. It's not just implementing something on top of NSO. It is something that is fundamentally has to be changed. Also, we do like that it is something that everyone, all of you, all customers would benefit of. It's not based on a specific use case and stuff like that. And it doesn't hurt if it has some innovations. We try to pursue patents when it's possible, and they come often from this part. The biggest problem here is that we don't know if the things that we do will work. So they need to be, we need to have the acceptance to fail. Because we are doing stuff that is a bit dangerous, actually. also, we need to do something that we can measure that it actually is beneficial. So often this is about characteristics, and that also is often or mostly easy to measure. But it can be also some sort of functionality, and that would then be something that we can't attain with the product today. It needs architectural design change of some sort. Most importantly also that it is backward compatible, because we do want this to be something that is highly adopted then. If it's irrespective of deployment and use case, it should not be something that it needs to change implementations to be able to do. So I said this is something that we have been working on for a couple of years. The thing is that we have been discussing this forever. I mean, nothing of the architecture is unknown to us, and we often discuss what could be done and what would be good. But the difference is that we now invest money in trying to do it boldly and try to fail fast if we should fail. And that is a big difference, because if we fail, that is also sort of good. Then we know something about our product and don't need to spend time on that part anymore. We also can see a pattern. It's almost like a process then. And that is these type of ideas, these type of things that are the design and the internal architecture, that comes from our own engineering. It comes from individuals working with stuff and being wanting something better. And we are promoting the idea that the individuals try out stuff on the side. We call that skunkworks. And that's a very good way for a starting point to see if something would be eligible for a research topic. And if it is, then we could start a research POC, just trying to get rid of old stuff and put something new in and see if it works. And that is something that the biggest problem that we have solved with this is that the first thing that anyone asks is, how long time will this take? And since you don't know if it works and what you should do, that is even more complicated than with a feature that you actually want to do and know what it's about. So you need to have really a agile approach to this. You need to report often enough what you are expecting to do next, how that worked, and your own recommendation if you feel that this works. So this is how we work with this. I'm good in time, actually. So past and present. Virvelvind was actually one of the first outcomes of this process. And that was a major change, I would say. And we had to adopt, not just implement an optimistic transaction control, we needed to adapt it to work with some innovations that we have. We also now have another research project that is coming in for 6.4 that is called Flintstone in our minds, but it is actually something that will be presented in the end of this day. So that's the cliffhanger. It's about memory reduction and also other benefits. So go and listen to that if you're interested. We usually don't talk about stuff until they are ready for release. But as you saw, the thing is that if you are issuing patents, that's very early. If you are not knowing if this will fail or not, of course, we don't want to promise anything at that point. But in the end, when we start a project, then we have the idea that this is something that we will pursue. So we might be able to, or should maybe be less secret about this. I don't know. The thing is that we can let up on one thing that we're working on right now, and that is Futurama. And we are looking into brownfield scenarios, the out-of-band changes that comes in networks, and they are always there. And what we try to do is to regard them as something else than before, that they are normal and that the network is the master, and how do we then secure services. So this is the thing that we can't talk about more than that. But hopefully, we can talk about it next year, because it's looking promising, and we hope that it will become a project soon. We don't know yet. Okay, so the other thing I said was the outcomes in form of patents, and we have a couple. I think it's 3 from Virvelvind and actually 2 more that might come in. And we also have 1 on the Flintstone side. So Victoria here will present one of the major things that we needed to do for Virvelvind.
Yeah, that's right. So let's talk about something more concrete. Okay, so when we were testing a lot Virvelvind, the prototypes of Virvelvind, then we noticed that the throughput improvements that we have vanished for services with overlapping device data. Let's see what was the problem and how did we solve it. But first, an example of services with overlapping device data, so you know what we are talking about. So on this picture, you see Service A. Service A creates an access list called NoWeb, adds an entry that disallows a certain host, and adds the last rule that is to allow the rest. Now comes Service B. Service B creates the access list called NoWeb, adds another entry that disallows another host, and then ensures that the rest are allowed. Fine. So why do these services overlap? Because both services create the NoWeb access list, and both of them add the last rule, that is to ensure that the rest are allowed. Shared ownership information is expressed by service metadata. We have reference counters, backpointers, and we have them for safety, so that there is no accidental device configuration removal. That is, if I remove service A, then the access list and the last rule still stays there, right? While service B is deployed. Okay, now let's see what was the problem. So from 6.0, we run service invocation outside of the critical section. We run them in parallel. That is to increase throughput. And this brought us a lot of benefits, but some challenges as well. And one of the challenges was this. So if I run service A and service B in 2 separate transactions in parallel, then let's see what happens. Then during service invocation, NSO is going to calculate service metadata. That is, it's going to read the current value of the ref count and the back pointers, calculate the new value, and then it's going to write it back. Right. So if I run these 2 transactions in parallel, then they are going to conflict. And one transaction will need to retry. Why? So the second transaction, the first transaction is accepted, that's fine. But then the second one is going to have a read-write conflict because the decisions it made are no longer valid. The first transaction invalidated it. That is, the value of the reference counter and backpointers that it read are no longer valid. It got updated. So this is a good thing because we managed to keep service lifecycle management safe. But it's a bad thing as well, right? Because it effectively serialized these transactions. So how did we solve it? We came up with a two-phase approach. You can check out the reference patents. The idea is that at service invocation phase, we do not, I repeat, do not calculate service metadata. We only record the operations, the intent. We record them as guarded commands. And then, when the transaction is persisted, at that time, we are going to apply the recorded guarded commands on the configuration nodes. So let's see this in action. So again, we have those two transactions at service invocation phase. None of them are going to read reference counters and backpointers. They're just going to record that I will need to increment the reference count by 1. It's a symbol that we record. And then let's assume service A enters the critical section first. And then it's going to apply the recorded operations. That is, it's going to read the value, the current value of the ref count. It's 0. Then it's going to increment it by 1. It's 1. And then it's going to write it back on the configuration node. Service B comes now, enters the critical section. It reads the current value of the ref count. It's 1, incremented by 1. It's 2. We write out 2 as the value of the ref count. No conflicts, right? We do similar magic with backpointers as well. And this gave us a lot of benefits. So we managed to keep service lifecycle management safe. We removed the difference in throughput for services that have overlapping and non-overlapping device data that are run in parallel. This method that we came up with, it actually effectively resolves service metadata conflicts automatically. So that removes transactional conflicts, and hence it removes transactional retries. So this gives NSO more space. It has capacity to do more. And as a bonus, we realized that we can use this for the commit queue as well. So we managed to rewrite the error handling, the rollback on error option in the commit queue using these recorded operations as well. So now we have a new way of handling rollback in the commit queue that's safe and secure, and it's pretty fast thanks to the new way of handling service metadata. Now you wonder what's next. Well, we can't really tell you. Sorry, then we would need to kill you. And this presentation is gonna self-destruct in 5 minutes. Thank you so much.
Okay. Thank you. We're going to shift gear again, and we're going to introduce the subject of the rest of the day, which is AI. For this, I will invite Javier, which is going to talk about AI. And that is a perfect fitting because they're going to consume a lot of energy, and we're going to do everything to reduce it. Go ahead.
Thank you. Good morning, all. So I'm going to be talking today about a concept that you might have not heard yet. It's completely new. I haven't heard this term mentioned, throughout the event yet, or even in the industry. And that concept is AI, right? So now more, seriously, right? We're talking about AI, and sometimes it is presented as a magic thing. So I want to sort of demystify this concept and explain it down into very simple, terms and principles, right? I'm not going to go through algorithms or models or anything like that. We can talk about that in any other time. But I want to bring this down into what are the key principles, what are the key reasons as well why AI is relevant for us. This is not a product roadmap presentation. For roadmap, you guys have Omar somewhere here to ask for him. But all the concepts that I will show in the slides, we have prototype code or demos, right? So what I'm going to show is real. It's not a fantasy. It's not just a PowerPointware. So there is a lot of opportunity here. All right. So I think I should put the sunglasses here. But hey, let's hear what is the industry saying. What are you saying? What are your leaders saying about AI, right? Plan, build, and operate. AI is not just about the operation part. It's about all the network lifecycle. It's about all the decisions that we make as we plan, design, build, and of course, operate the network. It's not about real-time data only. It's about looking at the data that we have from the past and maybe being able to learn or predict something of the future, right? It's analysis of past incidents. Autonomous. We've been yesterday hearing a couple of presentations and multiple times the concept of autonomous network. We're talking about that. Why now, right? We were talking about automation, automated. Now we're talking about autonomous. What is different? The difference is, now the autonomy means some system is making decisions, right? That's new. Generative AI. We're talking about generative AI all over the place. Why is this relevant? What will it bring? Part of it will be simplicity, like in layman terms, right? So we'll discuss about that as well. And there's also a very important aspect, right? That AI might make network engineers, better professionals, right? How to make a good engineer great. And that's all about, your professional evolution as well, your careers. You're all network engineers. So I think there's also a big aspect here, or how AI is going to impact us from a, personal and professional point of view. Another term that we hear frequently for many years is AI ops, right? Originally coined by Gartner in 2016. It's been used in a lot of different environments, IT, security, application, of course, networking, right? But because we are all engineers, let's try to break AI ops down into some easy equations so we can understand actually what are the ingredients behind AI ops. First of all, it's about how do we transform data with algorithms into operational insights, right? Things that we didn't know. Now, how with algorithms we can, transform, process the data that we get from the network into operational insights. But operational insights by themselves are not that useful, right? What you want is to make decisions. So now we need operational insights with knowledge, right? We can then take decisions. Where does that knowledge come from? Most of the time it comes from us, people, right? Or experience or background, right? With the operational insights that we get, we can take decisions. What do we need to do in the network? How to fix something? What is the best design? What is the best software release? All sort of decisions. But the decisions, again, themselves are not that useful if you don't enforce them, if you don't transform them into action, right? So then you need automation tools to take those decisions and transform them into actions. And of course, the actions, once executed, will produce more data, and this is the whole cycle that actually Gartner was explaining about. And there are strong opportunities to leverage AI in all the key enablers for the outcomes that we want. The outcomes are insights, decisions, and actions. But the enablers are algorithms that allow us to transform the data, knowledge, how we can leverage AI to automate knowledge. We'll talk about that in the session. And also how we can use AI to facilitate adoption of the automation tools, to make it more easy for you to use automation tools. One example, if you have to generate a workflow or generate a Django model or generate a template in any automation tool, can we use AI to facilitate that process, to maybe generate it automatically for you? So those are examples about how AI can help. And you will see moving forward, as we evolve our product portfolio, that we will start to leverage AI in all these different fields. Algorithms for data, knowledge automation, and how do we facilitate the use of our automation tools with AI. But let's step back a bit, right? I started talking about AI ops, but why? Why do we even need to talk about this now, right? Why we were talking about, this is about automation, this event. Why are we talking about AI, right? It's a very valid question. And I think the reason is here, right? We all are in the middle of a perfect storm. And it's going to be hard to navigate through it. And this perfect storm is the combination of several things that are going on, right? We talked yesterday about complexity, right? Of course, there are things that we can do to simplify architectures and so on, like SRv6, et cetera. But it's almost a fact that networks are more complex than ever, right? Measured in terms of scalability, number of technologies, even multi-vendor, et cetera. So it's definitely more complex than ever. But at the same time, what users expect from the network, the expectations are higher than ever. Again, you can measure it in the reliability they expect, the performance, the agility, right? Measure in any of the KPIs of your choice, but they expect more from the networks that you are running or you're operating. And then the people that you have to manage and operate these networks are fewer than ever, right? So it's a perfect storm, and it's actually probably trending even down due to the OpEx constraints. So how do we navigate through this perfect storm, right? Anyone? How do we navigate through this? Anyone wants to give an answer? Actually, I don't see much, but no answer? Please, one answer. Okay. Yeah, probably it goes there, but it's actually much simpler than that. It's automation. That's what we are here in this event. It's about automation, right? But it's automation at an unprecedented scale, right? It's not just what we're doing here. We need to reach a much higher level of a scale of automation to navigate through this. And now the next question, of course, is how do we get to that scale, right? Any idea how do we get to this higher scale? Automating more, right? We need to automate more to get to this scale. But automating more doesn't mean doing more of the same that we're doing. Because if we do just more of the same, we will not get there. And why is that? Because behind every activity, every task on the network lifecycle, again, design, plan, build, operate, any task, there are actions and there are decisions, right? But from a network automation perspective, the focus historically has been primarily on the actions. So we have been automating actions. We have been automating a software upgrade. We have been automating provisioning. We have been automating configuration. Those are actions. But actions and decisions are the two sides of the same coin, right? And they go together. And we have technologies, we have product solutions to automate actions. And the way to automate decisions is with data, algorithms, and knowledge, as I was referring earlier. So how do we get to the scale that we need? If we continue doing or focusing primarily on or only on actions, the decisions will become the bottleneck, right? Because the decisions depend primarily on the people. And what we need now is more decisions, better decisions, and faster decisions. It's as simple as that. How do we get there? Maybe we hire more people. Can we multiply the amount of people that you guys have in your organizations for 100? Probably not, right? Probably, there's no budget for that. And even if there was, you would probably don't even find so many, skilled people to do that. So what's the option? Well, the option is, we need to use technology to the point that we can delegate complete tasks, right? To automate both the actions and the decisions associated to those tasks. So we can actually augment what people can do with some sort of intelligent agents, right? Agents that can make decisions and that can automate actions. So go back to the original question, why are we talking about AI? Because AI is what unlocks decision automation. And decision automation is what we need to navigate through the perfect storm. So if you're wondering why in this event are we talking about AI and why are we going to continue talking about AI moving forward, it's because AI is just a natural part of the next generation automation, because we need to embrace decisions, right? We just cannot ignore that anymore. One very simple example, software upgrade, right? Software upgrade, we've been in one way or another automating the process, the action of the software upgrade itself with a method of procedure, with a workflow engine. We were talking about yesterday how we can do it with our workflow engine in Crosswork, right? But around or before the software upgrade itself, there's a number of decisions that you guys take, right? Among others, when I'm going to do the software upgrade, right? Or even what software release I'm going to upgrade this device to, or what is actually the MOP, what is the process that I'm going to use, et cetera, et cetera. Taking all those decisions at small scale by people or somehow manually, it's okay. But at very large scale, it's probably not going to be okay, especially if you need to make sure that there shouldn't be any conflict, any collision. You should properly upgrade every router and not upgrade routers simultaneously that you should not, and so on, right? So this is just an example of how, when you want to do this at scale, you need to start looking at how do you automate those surrounding decisions or previous decisions associated to the action that you want to automate, right? And this is actually one of the use cases that we are working on. But what do we mean when we talk about AI? Are we talking about LLMs or generative AI? No, or not specifically. We're talking about everything. We're talking about all the different techniques under the toolkit, what AI is. Yeah? AI includes machine learning, which is a part of algorithms that learn from data, and this includes, of course, generative AI and other techniques. But there's also non-machine learning-based techniques within AI that are extremely useful, and we are also going to use them. We're never going to be algorithm-centric. We're going to be problem-centric. Every problem that we have, we'll use the right tool for the right problem, not the other way around. So when you hear or when you see in this presentation or you hear us talking about AI, we're talking about all this, right? Not just generative AI or LLMs or anything in particular. So back to the AI ops, the key outcomes that we want, right? That all this is about insights, decisions, and actions. These are the fundamental outcomes that we need to achieve, and the fundamental building blocks from automation moving forward, right? Where historically the decision part has been dependent on people, so basically it was not automated. But now we need to start looking at how do you automate it. But before automating decisions, we need to have a strong foundation, right? And that strong foundation depends on having a strong insights framework and a strong action automation framework. And this is what we have been focusing from a portfolio perspective over the past years by building a proper portfolio of components and technologies that allow us to provide that visibility and insights as well as the actions that can be automated so that we are ready for the next step. The next step is about decisions, right? And it's not just us saying that, right? The whole industry is talking about now, how do we get to this concept of autonomous network? TM Forum has defined, the framework for the autonomous network, the different levels of maturity, to get there. Which essentially, if we map it to that, very simple framework that I was showing, right? We are very much ready from a perspective of actions and visibility and insights, right? And the components that we have in our Crosswork portfolio very much fit into this idea of different domains and how to automate and provide insights on a per domain basis, etc. But now the next challenge is how do we address decisions, right? And there's one important point to also highlight, that when it comes to decisions, it's about decisions in the entire network life cycle. It's not just we tend to sort of implicitly think that, hey, AI will help us in making decisions when there is a problem, detect anomalies, do event correlation, and that's part of it, right? That's the reactive part of it. But we should not forget, and I think we have maybe underestimated the importance of the proactive part. All the other decisions that happen before a problem happens. Because if you have an infrastructure, when something fails, you definitely need to have real-time telemetry, real-time operational insights, be able to detect whether there is anomalies or not, be able to reduce the noise by correlating multiple events together, and eventually get to a root cause analysis and remediation. This impacts some of the key metrics that we usually talk about. Mean time to detect, mean time to innocence, mean time to repair. But there's a lot of decisions that happen before, right? That happen, when we design, when we build, when we create, when we manage the network, and that drive the behavior of that network. And in that process, influence as well whether the network fails or not, or how frequently it fails, right? And this is based not on real time, but more non-real-time insights. It's about identifying potential anomalies that are deeper in the infrastructure or potential risks that we were not aware, right? Or also make better decisions, align decisions with your organizational goals. We've been talking this morning about sustainability. How do we make sure that the decisions we take on the network, design, paths, topology, and so on, are aligned with what the organization wants? That drives the behavior of the network as well. So ultimately, it's about taking better decisions. And what this influences is our MTBF, how frequently the network fails, right? And both are impacting directly the customer experience. So let's not focus only on MTTD, MTTI, MTTR. That's important, but let's also start considering MTBF and what can we do to prevent failures? What is the opportunity to act more proactively, okay? So a couple of example use cases. One, I will not spend much. You've seen it this morning in several of the presentations, the work that we are doing to provide deeper insights and decisions that optimize your infrastructure around sustainability goal, power consumption, emissions, et cetera, right? How do we make sure that the decisions that we take are aligned with our organizational goals in that sense? This is another interesting use case where we can use algorithms to surface risks on your network, what I call toxic factors here. Toxic factors that could be maybe a software release or maybe a combination of a software release with some hardware, right? There's always things that might be, working, suboptimally, let's put it this way, in the network and causing certain failures. Failures such as maybe interface flaps or BGP issues or connectivity issues or authentication issues or interoperability issues, right? And how to find what is causing that or what is associated to those, right? So we have the data and we have the algorithms. We can bring them together to try to surface those risk factors. And if we identify them, then we can avoid them. If we can identify that, hey, this software version with hardware version is not working well, it's behaving toxically, right? Okay, let's avoid it. Let's change the software, or let's at least be able to do something about it. And these are techniques that the AI toolkit, makes it available for us, let's say, to use them. It's just a matter of applying them. Generative AI. Who uses generative AI, like ChatGPT and so on a daily basis? Can you raise your hand? Yeah, probably 30, 40%. There's still 50, 60% here that are not using it. You should use it. That's my advice. But why is this relevant for us, in the context of networking, like, this type of language models? There are two aspects of this. One, mostly tactical, maybe short-term, low-hanging fruit maybe, and one that is more transformational. The tactical part is that, language models, the way they have been trained, this idea of predicting the next token or the next word, basically makes them very good at anything, any task associated to natural language, right? And what happens is that in networking, we have a lot of forms of natural language that we work with. We work with configuration files, we work with log messages, syslog, and so on. We work with support tickets, we work with workflows, templates, YAML, JSON. These are all forms of natural language. So language models are very good at doing things with it, at interpreting the semantics, at being able to summarize, at being able to classify, maybe at being able to generate new. So you will see, both definitely from us and probably from others, how more and more use cases are developed in the automation products around leveraging LLMs with this type of data, because they fit very nicely, right? But there is some more transformative aspects of what LLMs give us in our context, and also in many industries as well. And it's about the concept of knowledge, right? Knowledge automation, or knowledge potentially in software. Knowledge is a kind of weird concept. It's difficult to define. I'm not going to read that, and I don't want you to read that either. But it's a sort of combination of multiple factors. It's about experience. Of course, it's about information. It's about connecting, context with experience, with data, understanding relationships, perception. So all those things together. And basically, that means that historically, knowledge has depended on people, right? Depends on us, because we are the source of knowledge. And when we need knowledge, we ask people, right? So that means it's an inherently scarce resource. It's limited, right? But what happens now, we have LLMs. And LLMs are effectively behaving as huge knowledge compilers. So a new form of knowledge, not exactly as the human, but in similar shape, it's available at the distance of a software API call. And that changes things a lot. Right? Something that was inherently scarce, now it's elastic, it's scalable, let's say virtually unlimited. Right? So the combination of knowledge coming from people plus knowledge coming from software enables us to rethink processes, to rethink paradigms, and do things differently potentially. So that is very transformational. What does that mean for us in networking? Well, maybe that might help us in this journey towards what we've been talking about, the autonomous network. We have the model and so on, but how do we get there? We're always talking about, hey, okay, we'll do more closed-loop use cases, we'll get to level 3, level 4, level 5, whatever that means, but what is new that will allow us to do that final step, if it will? So, we've been in a journey of making networks more and more software-based, like SDN in practice, right? And the actual trigger, the actual enabler for that process was the standardization of APIs. So the more standard APIs there are in the network, the more software entities were developed, right, that would interact and would configure, would act on those standard APIs. But at the same time, more network data became available, right, through those APIs. The consequence of this is more decision points on the network that software can interact with, and the possibility to optimize those decisions, of course, with data and some type of algorithms. And this is where we are today. We have an SDN, which is, of course, this is a very simplified view, but I told you my session was about, trying to bring things down into very, very simple concepts. This is where we are right now. What's new? Well, on one hand, cloud is new. So the cloud infrastructures, cloud resources allow us to do things differently or maybe new things. But particularly, LLMs are new. This thing didn't exist 2 years ago. Or it did exist, but it was not, at the, let's say, with the power that they are now. So if we take the LLM and combine it with cloud infrastructure and combine it with network data, now we have networking knowledge in software. We have truly networking knowledge in software that we can access through a software API call. That's new. We didn't have that before. We had rules. We could create rules, but we didn't have more complex, elaborated, dynamic knowledge. So with knowledge in software through the LLMs and all these decision points and the possibility to optimize those decisions, we have the opportunity to build autonomous agents. And I will explain what I mean, right? But these autonomous agents, in combination with the software-defined infrastructures that we have these days, set a clear path towards that ambition, which is the autonomous network. We didn't have this before. We couldn't build autonomous agents. We couldn't build networking knowledge in software before because we didn't have LLMs. But now we have them. So this is a new ingredient for our networking industry that sets a clear path that we can execute towards that end goal. What are these autonomous agent thing that I'm talking about here? We know about LLMs. You all know about LLMs. Some of you actually use them in your ChatGPT interactions and so on. And they are very good at responding to a question. An LLM is basically a mathematical function. You make a question, you get a response. That's about it, right? They don't do anything. They don't have like productivity or anything like that. It's just a static mathematical function. But they are good at that, and they behave in a very imperative way, right? You make a request, you get an answer, right? And which is typically some type of summarization, translation, answer, etc. But now we can use LLMs as the brain of a more complex software system. A complex software system that is intended to solve complex problems, right? And how can it solve complex problems? Because it self-plans how to go about your request. You make a request, you state your intent, what you want, what tasks you need, and they can self-plan, they can build a plan. Okay, I'm gonna do this, this, and this, and this to solve this request. And in that plan, they can execute actions and functions, right? So eventually, they can, as they execute autonomously this plan, they can provide you a response, right? When we think about intent-based management that we've been talking about, for many years, this resonates very closely, right? You state your intent, you don't define the how. Somehow the how is figured out automatically by the agent, and eventually it's executed, right? This is real. I mean, this is being explored in all industries, but there's a real opportunity in our industry to leverage these principles, these architectures, as a way to enable more comprehensive task automation, which includes both actions and decisions. But we don't need to stop here, because there's also multi-agent architectures where we can combine these things, where agents talk to each other, right? Agents that might be specialized on different tasks, on different functions, or maybe you can have a swarm of agents executing a mission. It's just all possibilities, right? And it fits very nicely on how we could get to this end goal of the autonomous network. Just one example, right? Of and again, we can show this in our prototypes. Let's say you have a network and you have some BGP problem, right? And of course, you need to troubleshoot where is this coming from? Why is the BGP session down? Which could be for many different reasons. I mean, there's some configuration issue, there's reachability issue, I don't know, whatever. It could be many different reasons why a BGP session goes down, and you don't know, right? So you need to find out. And typically, a network engineer would go and troubleshoot this. So based on your experience, your knowledge, you would go step number one, I will do this. If it is not, then I will do this, and so on, right? But now we could have agents that do that on our behalf, right? You could ask an agent, hey, this BGP session is down, why is it? And then there will be a diagnostics agent that would plan, based on your request, how do I troubleshoot this issue? And it would produce a plan, right? And that plan would have step number 1 to N that would try to execute to find the root cause of why the BGP session is down. But this diagnostics agent will spin up other agents that will help in searching the information that is needed in each of the steps. So step number 1 maybe requires, hey, I need to have a look at the configuration, the BGP configuration on the two end devices to see if there is something wrong. So there is another agent that will be called to say, hey, find the configuration on these 2 devices. And this other agent will be specialized on that. So as part of that request, and because it's an agent, we'll plan, how do I find this? Well, there's a plan on how to search that information. And probably the first step is, what are these devices, right? Are these Cisco devices? Are these Juniper devices? What is this? What is the IP address so I can connect? So maybe it needs to check with the inventory first. And then once it has a response, then it will go and check. Same thing that you would do, right? In your logic to troubleshoot or to find some information. So the same thing we can expect or we could achieve with agents in collaboration to solve a certain problem, right? A complex problem for which otherwise you would need knowledge, right? Human knowledge. But now these agents, based on their little brain, which is powered by an LLM, they do have knowledge, right? So if we build this, and of course, this is still going to be a journey, and we're still sometime we will need to mature this. LLMs will need to get better, and so on. But I think it's promising what we can accomplish, and based on the results that we are getting. Okay. So then, if you think about that, this type of agents might become available, you could rethink the way we approach maybe network operations, or the way we approach network automation in general, because it's software, right? Of course, there's always limits in software, and of course there are costs and so on. But you don't even need to be limited to spinning up one agent. You could spin up 1,000 agents for a specific task. Of course, you cannot have 1,000 engineers, but what if you could spin up 1,000 agents to troubleshoot a problem, and they all will search in parallel, right? That could be an option, or 1 million. So, it's just possibilities, right? And there's a lot of different use cases that this type of agents could address. So it's just something to, also for you to consider, to think about how LLMs and architectures enabled by LLMs, like this type of agents, can transform the way we approach network operation and network automation in the future. And I think it's very promising. So what is the implementation journey then around AI ops and leveraging AI in the network or in the network lifecycle? Step number 1, actions, right? We need to make sure that we have a strong automation framework foundation. And of course, we're doing it with our portfolio of automation products, especially NSO, workflow manager, controllers, etc. So that's also on you as well. Make sure in your journey that we have a strong automation foundation. And what we will see moving forward is that there will be more and more AI embedded into these systems, especially driving simplicity, helping you use those systems and accelerate processes as you use those systems so that it becomes much easier to automate multiple types of actions. Step number 2, insights. That's the other key foundation that you need to have. And you will see as well how the products will evolve or will expand, not only on the reactive side of insights, but also, or especially on the proactive side of it, right? So that we help you in the decisions that you need to take, not only when a problem happens, but also decisions that might happen before, and that will impact maybe how frequently or how less frequently the network fails, or how to align or optimize your decisions for your organizational goals, right? And last but not least, decisions, right? And how do we leverage the potential that generative AI brings to automate knowledge, to turn knowledge in software, and eventually use or start leveraging this concept of autonomous agents that might allow us to rethink the way we operate, the way we do things, or even transform the overall network automation, right? So this is sort of the journey, but just want to make the emphasis, the first 2, actions and insights. This is something that you can start doing now, right? Do not wait until you have all the mechanisms and techniques for decision automation. Because if you have them, but you don't have a strong foundation of actions and insights, you will not be able to fully leverage the opportunity. And just to finalize, right, we're at the beginning of this. This is especially the last part, the opportunities of decision automation, generative AI, and so on. We're in the infancy. We've been only 2 years in, if you will, for many of these. But it's really promising, and I think as we go forward with network automation, we will see more and more that it becomes just a natural part of it. Probably the next instances of this event moving forward, they will have AI just as part of all the different topics that we discuss and that that we develop and that you deploy and implement, right? So thanks for your time. This is the end of my session. I don't know if there is any question or comment.
Yeah, go ahead. We're going to display 2 questions.
Okay.
Do we need domain network specific, fine-tuned for LLMs?
That's a good question. I don't think there is a right or wrong answer to this. I'm going to give my opinion. I think we don't need them. I think the big LLMs today have already a strong knowledge. I think there might be a possibility to add more knowledge, but a lot of the additional knowledge that we can add could be added through other mechanisms that are not fine-tuning. Because fine-tuning for knowledge, right, which in some cases might be associated to fine-tuning for facts, right, might have a consequence that the model might forget previous knowledge. So I feel inclined to think that probably the big LLMs will be good enough for most of what we need to do. And we need to play with our domain area or domain-specific or company-specific knowledge bases using RAG techniques and others. But that's my belief at this point. We'll need to see if that changes or if there is a true need to have a network-specific LLM.
Okay. Second question. Are there any actual implementation use case that we can take a look at it and discuss, or is it a world presentation about possibility?
So when it comes to implemented, like deployed in production and so on, not much. But as I said at the beginning, all the concepts that I've shown here on this slide, talking about software upgrades, talking about toxic factors, preventive insights, talking about agents and so on. For all of these, we have prototypes and code, and we can demonstrate it. I mean, if any of you are interested, just reach out after the session, and we can definitely set up some time. But this is real. It's not just like a PowerPoint fantasy. But there's, for some of it, especially when it comes to the agents and the LLMs, there's still work ahead that we will need to, and research that we will need to do. But the results so far look promising. Yeah.
Okay. Thank you for...
Thank you.
One question in the audience, too.
Okay. I cannot see anything. Okay. Good. Thank you.
Thank you. That concludes our morning sessions. I will invite Pradeep to give you the update of what's going next. Or
Go ahead. So we have the quiz. Since we ran a little bit late this morning on the agenda, we skipped the quiz in the morning. But now we'll just run a few quick quiz questions.
Hello, everyone. I'm back again just to see if the sessions were great. I'm sure they were. So we did some quiz yesterday. We have picked the winners, but we will launch the names after this quiz. So we have separate slots, and for every slot, we are picking new winners. So I would like you to join our Slido. So if Siri wins, you will have to give me your email address or something so that I can reach out to you and send you your gifts. So 75. Okay, I think we'll get started. So this is your first question on the screen. You have 30 seconds for every question. So 3, 2, and 1. Let's go and see what was the correct answer. So HTTP 2 and our leaderboard. So we have the winners already for the first question. Moving to the next one. What does serverless infrastructure provide to an end user? Final few seconds, but I think all of you have provided an answer. So this is the correct one. Moving to the next. Oh, we have some updates on the leaderboard. So next one, what does Information Security CIA Triad stands for? Three, two, one. Moving to the next. Let's see if there are any changes. Oh, Robert is doing quite well. Now, one on Ansible. Okay. Moving to the final question before the lunch. So we have 87 participants. And with that, we are coming to the leaderboard for the first half for today. Congratulations, Robert and Mark. You are going to get something from us. So just reach out to us during the lunch, me or Nicholas, and we will hand out your prizes with you.
Yeah, and we will also flash winners from earlier quiz when we get back to from lunch. So you can all come up to us. We're here to hand out the prizes. So yeah, continue with the engagement and don't give up if you haven't won so far.
Yeah,
right?
we are going to have second section, which will again start from fresh. So if you haven't won again in this one, you will win in the next one. Reach out to the speakers, say hi, tell them, because they have spent a lot of time preparing those sessions. So if you have enjoyed something, give them a feedback.
See you back
Thank you so much.
1 p.m. Bye-bye.